Good morning and welcome to the 2020 AI Conclave. I am Rachel Slattery and it is my great pleasure on behalf of the team behind Tech23 to welcome you to today's event, which we are hosting in partnership with AWS and Intel as part of the 2020 Tech23 Deep Tech Festival. As is custom, I would like to acknowledge both the Gadigal people of the Aurora Nation and the Boon Wurrung and Wurrung Wurundjeri people of the Kulin Nation, the traditional custodians of the land where the Slattery's team meets, works and creates. We pay our respects to the elders, both past, present and emerging. We also acknowledge that people are attending today from other traditional lands and nations and extend our respect to their custodians, ancestors, elders and future leaders. Always was, always will be Aboriginal land. I'm so very pleased you have been able to join us for what is sure to be a fantastic couple of days, learning and exploring AI and machine learning. I can feel my head hurting already. It's a great lineup and I'm looking forward to hearing how some of our favourite businesses are advancing their businesses with AI and ML. Tech23 is coming to you any which way this year. We have started the circles, which have been wonderful online conversations, diving deep into areas such as medtech, quantum. So please check out the website because you're welcome to come and eavesdrop and connect at those. We've also got some of the investor briefings coming up. So for the investors in our midst, please check those out. And of course, for those lucky enough to join us in the flesh, we are looking forward, we're very excited actually at the prospect of the long lunch on the 10th of December, where the amazing Mike Walsh will be sharing with us. I'd now like to welcome and hand over to our host today, the head of the startup ecosystem for ANZ at AWS, Colette, and also from AWS, I have Rohit, who will guide us today through the proceedings. So please give them a warm welcome and enjoy the conclave. Thank you.
Awesome. Hello, everybody. Let's get this started. Shout out if you can't see my screen. Otherwise, I'll assume we're good to go. Hi. Thanks, Rachel, for that wonderful welcome. It's super exciting to be here with everybody today. And if you're joining us, especially from Victoria and especially from Melbourne, I just want to say thank you so much for using your freedom days to spend with us today. You're bound to learn a lot and I hope that it's going to accelerate you on your journey. So I wanted to kick off with this quote, because no presentation that involves AWS would be fair and fit without a show up from Jeff. And in case you thought I was going to use this quote around invention and unleashing creativity in others to talk about AI, I'm not. You're going to hear about a lot of experts today that can talk to you specifically more about AI. I actually want to use this quote to talk a little bit about generosity and community. And first, just thank our partners, Tech23. Rachel, you guys have been building the ecosystem in the startup community in Australia for the last 10 years. And there are many, many other partners who are doing that. And opportunities and events like this are a great way for us to come together, to connect, to learn from each other, and to accelerate our success in all directions together. So I encourage you, if you're joining us today, reach out, ping the speakers, say hi, ask your questions, participate, because this is what it's for. Over my time, I've been involved also with the ecosystem as a founder, working in research commercialization, dabbled a little bit unsuccessfully into investing, learned my lesson. And over the time that I've been in the ecosystem, I've seen so many different startups and so many reasons why startups fail and succeed. And there are 6 reasons that it boils down to that I've seen over time. 6 things that really make a difference to startups. You can bucket them into runway and resources. You need customers, you need cash or credit to get started, some money. As you're growing, you need capital to give you the runway ahead. And then you also need resources, because you can have all the runway in the world and none of the resources and you'd still go nowhere. So you need team and talent, you need teachers and training, and you need technology. And one of the reasons why I've loved stepping into this opportunity, and it's a huge opportunity to help grow the ecosystem in Australia and New Zealand for startups, is that, and I get to work with a team that actually spend their entire days thinking about how do we make this available to startups. And as a result, these are some of the reasons why startups love working with us too. We also have a lot of engagement with the ecosystem. Over time, there's now, well, there was a few months ago shortly, 450 co-working hubs. There's about 120 accelerator programs and incubators, and about 170 VC funds in Australia. And it's been remarkable to see this growth happen. And now suddenly to see that as AI is getting more of a prominence, and as we're seeing all of the problems that we can solve in the world with that technology, how many of these different groups are clustering around AI opportunities. And it's really remarkable to partner with them and to watch and to support them in helping founders get their companies up and running fast. When I actually talk to startups, one of the secret sources that we have in the AWS startups team is that we have a team full of people, and this is just the team that I work with, that live and breathe startups. Like, we're from the ecosystem, for the ecosystem. We're here to make sure that that we play the role that we can to support you in your growth. And we're all over Australia and New Zealand. So I encourage you, if you have a quick squiz at the names, reach out to somebody in your city or your vicinity, say hi. If you have questions or follow-up questions that you have after the session, you can ping any of us. We're very happy to always talk to founders and startups. And there's two ways, really. When I think about our mandate, is to make sure that we help to accelerate the success of startups on Earth. And I like to put a little parenthesis in there around meaningful startups and startups tackling big problems. But we do that in two ways. So helping you out when you start. So when you first start, we do things like removing barriers, any cost barriers that you have. So we do issue credits for founders getting started. Everybody is eligible to get started with $1,000. And then as you grow, you can apply for up to $100,000 in credits to help help fund and support your growth. And then we also do things like providing training, office hours with amazing people like Dave, who you'd hear from later today. And also helping to grow your business through spotlighting some of the great work that you're doing in our marketing channels. And then the second part, so once you've started, then we focus on how do we support you as you grow in that journey, and how do you scale? And that's really where we do a lot of one-on-one work with growing companies to connect them into bigger enterprises if they're doing B2B deals, or connecting them into VCs if they're looking for capital for growth. And that's both locally and internationally, because we're part of a team across the world that basically just focuses on helping startups succeed. And we also make sure that you connect to each other. And this is why I get so excited about the work that Rachel and the gang at Tech23 do, because they're really building that fascia and that connection to make sure that we learn faster from each other and succeed together. So a last final note as we head into the next 2 days, AI solves everything, right? I'm waiting for somebody to say this later today. But my challenge to you is, which problems really warrant your time? Like, this has been a year where in the last year, some of the biggest challenges that we've ever seen have come at us, with bushfires and devastation, COVID and the health effects of that, the economic flow-on effects, and then very importantly, also climate change. So these are some big problems in the world that before, when we're thinking about how do we solve them, would take us decades to run simulations and try and figure out how can we solve them. And as we're going on to tackling these big opportunities, the question for you is, how do you want to spend your time, and where are you going to devote your energy and passion to? And one of the things that I'm most excited about when I joined AWS a few months ago is that we've actually taken a stance on climate and made available a $2 billion climate fund. And this climate pledge fund invests in things that I think we will hear a lot about over the next couple of days. So I thought I would bring this up for you so that you know about it. You can find out more on the website below. But we're looking for what are some ideas that's going to have significant step change impacts in food and agriculture, transport and logistics, energy generation, storage, utilization, optimization even, especially around for Australian manufacturing materials, and then in a circular economy. And this is really something that's near and dear to my heart, and you'll hear me talk about this quite a lot over the next few years, I hope. But I challenge you as we go through today and we learn about what the technology can actually do. And we hear from founders who have actually taken remarkable steps in these different areas. What is it that you can do? What is the opportunity for you? And how can you lean in and connect with us, connect with each other, connect with founders, and then let's take action and solve all the world's problems. And with that, I just wanted to say thanks very much again for joining us today. Enjoy the day, stay curious, stay excited, and stay connected. And I'm going to hand back over to Rohit, who will introduce our speakers.
Thank you, Colette. Hi, everyone. As Colette mentioned, I'm part of the startup team. And again, as Rachel mentioned earlier, I will be your guide for over the next 2 days. So just a few notes from me, primarily on housekeeping over the next few days. So you will have seen in your reminders a link to Slattery's community charter. Always a good read if you need guidance on your behavior that is encouraged at this event. Also, a few other things worth noting. We encourage you to make use of the live chat. Please feel free to use it to introduce yourselves and share any useful information or resources, and to, of course, throw in any of your burning questions for our speakers for today. We will also be recording the sessions, and they'll be made available to registered attendees on demand post-event. And finally, we'll be keeping intros brief today, so we can get right into it, and so you can read up on all of our amazing speakers on the AI Conclave website, being shared now in the chat for your convenience. We extend our sincere gratitude to every one of our speakers over the next 2 days, and want to thank all of them for taking part and sharing their insights with us. Without further ado, I'd like to introduce our first speaker of the day to kick things off. David Lempers is a serial entrepreneur, inventor, engineer, and applied data scientist. In his current role at AWS, he works with founders to identify and adopt leading edge technologies. Speaking this morning on AI/ML in real life, popular patterns and use cases, please give a warm welcome to Startups at AWS Head of Technology, Dave Lempers.
I had to talk about this topic and want to jump straight in so we can get started. So one of the things that I really enjoy talking about are kind of like the key use cases for AI and ML. I think one of the things that strikes me most about this is it's largely based on my own experience as a data scientist. What I'm hoping for from our session today is that we can essentially stimulate a conversation, as Colette said, have everyone starting to think about what are the main areas that they can take some of this learning and apply to their own business. But really, I want to just kind of talk about those those kind of main use cases and scenarios. Ro already did a great introduction. I won't go into myself. Otherwise, that I'm from AWS. I've got a deep background in data science, both as a principal applied data scientist, but also as a founder as well, and also as an author of AI/ML patents. One thing that's really important for me when I think about AI is just what a significant technology change it's been, and probably the largest, since the mobile wave. Colette mentioned it. It pretty much is everywhere. There are solutions for just about everything, around AI. And so again, we really do encourage, our founders and technologists to be thinking about how they can apply AI and ML, to their businesses. Today's session, my goals are really just to cover those main use cases and scenarios and patterns that I've certainly come across or worked on as an applied data scientist. I want to talk a little bit about the motivations behind it, and I want to map it back to us as humans. So one of the things that's challenging about AI is we have to kind of develop this intuition for what is the AI or the ML doing. And I've personally found in my experience that when we can tie that back to how we think as humans, it really really helps us understand why the AI is so compelling and why it's capable of essentially working together with humans to solve problems that by ourselves we wouldn't be able to solve. So again, we're going to go through kind of those core AI solution types. We're going to understand some of the benefits. We're going to talk a little bit about the motivation, and then we're going to dig into the science behind it. So the first one I want to talk about is personalization. And for me, it's the one that I've dealt with the most in my career. I've worked on it, at systems as big as kind of Bing, and personalization, and as small as kind of, recommendation systems for personal shopping and product recommendations. I think one of the things that is really exciting about personalization is it overcomes two major challenges we face as humans. But to talk really quickly about the value prop and what's that motivation for us as product engineers and developers, is it really helps with increased conversions. So any situation where you have a customer going through a pipeline and you want to engage with them and increase those conversions, personalization is the first place to look at. In my own experience, worked on projects where we saw increases in conversion of 26%. Just based on personalization. And in fact, when you look at things like email revenue numbers, you can see growth of almost like 760% in some cases. So there's a very compelling reason to consider using personalization in any process where you want to increase conversion. So why does it work? Well, fundamentally, there's two major things that drive it. The first one is an idea called cognitive distortion, or specifically within cognitive distortion, a concept called control fallacies. And really, that's just our own innate desire to control our environment and not to be controlled. The second one is data overload. And here's an interesting fact. We consume about 35 gigabytes of data per day. And to give you a sense for what that looks like, your average 30-minute TV show is about 1 to 2 gigabytes in size. What's interesting, though, is that we consume data, we can process data at about 15 bytes per second. So when you start to do the math, that's a lot of information that we're having to process day to day. And so what happens is we end up overloading and fatiguing, and our brains kick in with this idea called attentional filtering. So we start to look at all this information and prioritize the most meaningful or the most critical pieces of information. And it's actually why shopping cart abandonment is such a problem, because a lot of people, when presented with a lot of data and the desire to feel in control, will largely use attentional filtering to not deal with those tasks. So I think what's really interesting about personalization, if we think about how it works in the background, is these two core concepts that really look to deal with this issue that we have of control and data overload. And the first one is called content filtering. And at the core of it, it's really that we are more likely to like stuff that we've liked before. So if I happen to like shoes, I'm more likely to like shoes. If I happen to like hamburgers, I'm more likely to like hamburgers. The second one, though, is called collaborative filtering. And that's really the idea that we're more likely to enjoy discovering things like people like ourselves. So in this example, Canadian tuxedos. And so, to bring these two things together, both content filtering, this idea that we like things that we already like, and collaborative filtering, which is we are more likely to like things from people who are like us, and that's a lot of likes, is we're going to look at the Spotify use case. And so what's really interesting about Spotify is they have dedicated teams who are indexing artist information. So they're getting all that, content information. They're scanning and measuring acoustic signals in the songs, and they're labeling those for their training set. So we can understand things like genre and style, tone and tempo. And then their algorithms use that to build a model for what our preferences will be. And what ultimately they're hoping to do is reduce the cognitive load on us as customers for having to discover music that we like to hear and not waste time listening to music that we may not enjoy. So that's the first part. And then the second part is, as they build that graph of the music that I like similar songs, they look at what other people listen to those songs as well. And then they start to look at what they're listening to. And they do this serendipitous exploration experience where I start to discover music that other people are listening to based on the fact that we intersect on songs that we both listen to as well. So again, very, very powerful personalization strategy, leveraging both content filtering and collaborative filtering. The second one I want to talk about is prediction. And really, this is where we're using historical data to help us predict some kind of future value. And you see it used in systems like Redfin and Google Maps. So really, any business where you're essentially trying to make good guesses, using AI to improve that function is crucial. Everything from predicting customer churn, more efficient planning, better predictions mean that you make better decisions ultimately. So why does it work? Predictive algorithms use two main features that our brains aren't very good at. The first one is correlation, and this is where we create an association between two values. Prediction algorithms are capable of doing that very easily along very large sets of data. But we also lack, or we have limited what's called spatial abilities. So we can think very easily up to about 3 dimensions. But once we start getting past that, our brains don't do a great job of making good guesses. The second one is temporality. And so the idea behind temporality is both reducing the window of data that we take into consideration when making a prediction. But, and when we think about the classic example of predicting stock prices, we tend to want to look at the most recent behaviors of a business that might predict, its stock price rather than looking at long windows, historically. The second part of temporality is this idea of seasonality. So while we may only want to look at a very short, meaningful window when we're looking at doing prediction, there are times when we want to maybe look at a longer window or longer interval, but look at very specific points. So a classic one is the bobcat problem, where they seek to understand the behaviors and lifestyle in the ecosystem of bobcats. So they go back and they look at a very specific interval every year. And so that's a little different interpretation of how to use prediction. Is you're going back seasonally, maybe you're looking at, for example, a particular sales period. And so you're always going each year for maybe 10 years, but only for a very short interval in time. And so both of those concepts come together in our ability to start to make really good guesses, and kind of predictions. So how do they work? Well, really, at the end of the day, they're just trying to map how we as humans make guesses. And that can either be through techniques like statistical regression or decision trees or neural networks. It doesn't really matter what method you use. They are essentially trying to generate possible outcomes and then work backwards from those to weigh the likelihood of those outcomes given a certain set of inputs. And then they just produce an outcome and the likelihood that outcome will occur. A great example of this is Google Maps, using predictive traffic models to help, find low traffic routes. They take in a number of factors. And so this is, again, where if you're a human and you're trying to factor in things like traffic, if there's been an accident, maybe there's like inclement weather. So there's even sources of data we may not get access to that a machine can. And the machine's able to take all of that information, process all of those dimensions, and come up with a likely scenario that ultimately serves towards our goal. The next part is anomaly detection. And this is where we're really searching for items or events that don't conform to the data set that we're looking at. And you definitely see this the most in systems like internet banking, for example, or even like security surveillance. What's interesting is modern systems generate an enormous amount of data. We have this kind of data overload. And it's just impossible for humans to process that level of data, and certainly more difficult for us to look for things that we're not necessarily looking for. So we're good at pattern matching where we've seen something, but analyzing patterns where we're not seeing something and detecting anomalies is a lot of work for our brains. So this ultimately leads to either loss of data or fraud, and these are the kind of scenarios that we find. AI-based anomaly detection has the ability to quickly, accurately, and reliably detect and also respond, right? Trigger those actions should those events occur. So why does it work? Well, our brains work in two normal modes when trying to identify something as normal. So the first one, and what's interesting is they're independent, right? They're not happening at the same time. So when we have to operate these two things in parallel, that's where it becomes really tricky for us. So the first one is this idea of probabilities and patterns. How do we know if something is expected or not? Well, the first one is we can think probabilistically, right? For example, we know 2 out of 3 times, I'm more likely to order takeout on a weekday if I've worked past 7 p.m. It involves a certain level of uncertainty, but our brains do a great job in what's called outcome reduction. So given a binary outcome, we rarely land on the 50-50 probability. The other approach is pattern-based. So the example I always use is, for at least once a week, my mom will call me. I don't know what day necessarily, but I definitely know it's at least once a week. So if for some reason she doesn't call during the week, I can detect that anomaly and react. And at this point, the role of uncertainty is replaced because you're no longer dealing with probability, but more of an irregular pattern, made regular by an interval. In this case, like a 7-day window. So the challenges arises, however, when those two things come together. And so when we try and inspect events, for example, once a year, my parents take a holiday for about a week, and 2 out of 3 times they still call, during the week, but then sometimes they don't. And that's where making a pattern-based probability decision is very hard for our brains to do. So why does anomaly detection work? Well, essentially what it does is it brings both of those aspects together. It looks at elements in our data set, builds a statistical model based on clusters of similarity, and then given a new element, such as a transaction, measures the distance from the most common elements. And this provides a probability to the element belonging to our data set. And this is really crucial to how AI anomaly-based detection works. So we're not necessarily trying to classify, is this a dog or a bunch of cats? We're trying to answer the question, does this look like it belongs to our data set or not? And if not, how badly, what's that kind of confidence value, right? And should that also trigger some kind of outcome like a review or a human to get involved in the process? Stripe is an excellent example. They've got some wonderful science posted on their blog, but they use anomaly detection heavily, for the financial transactions. And what's interesting is they're using a number of different AI strategies. And so this is really important for you to take away, is that there is no one model to rule them all. Ideally, what you want to do is use this idea of micro models, right? Very small machine learning models that achieve a single function, and then you chain them together or orchestrate them together to serve your solution. So in their example, they're using both classification, which is answering the question, is this transaction fraudulent or not? And they're also using regression, which is is the amount of this transaction within a normal kind of boundary. What's also interesting is, they leverage another technique, right, which is just using a very large data set to get started, and then they kind of refine and tune that data set per customer. So, it ends up speeding things up and gives the machine learning a better sense to deal with transactions that they haven't seen before. So how does anomaly detection work? Well, again, sorry, so supporting methods behind this, and I don't want to go into too much detail about this, but there are a number of different underlying capabilities in AI and ML that support these different core scenarios. So the first one is natural language. And, this is really one of the key supporting methods that you'll see certainly in things like classification. And this is where you're training a machine learning model to understand, interpret, and manipulate human language. You see it used in voice-based assistants like Alexa, semantic ranking scenarios like Google Search, and translation services like Amazon Polly. The other one is classification, and again, another very important supporting method that also leverages natural language processing in things like product recommendations. But this is where you're extracting characteristics of a subject, such as an image, audio file, body of text, and you use those characteristics to categorize that subject according to a taxonomy. So again, any of those kind of image search systems are using this technique heavily. So that, again, very quick speed through of the core scenarios that certainly as an applied data scientist, we experience and see in a lot of systems. But I also, again, when I think about my own experience in startups and building products for new markets, these are definitely the areas where investigating and experimenting and starting to consider how you would add those into your products and services can yield some really wonderful outcomes. So I'm going to pause there and then kind of hopefully take some questions if there are any.
Fantastic. And just a quick reminder to everyone tuning in live that you can submit any questions that you have for David via the little chat window that you can find at the bottom of the screen. So Dave, just I guess pulling on some of the things that you mentioned earlier in terms of, obviously there being no one model to rule them all and potentially looking at sort of building out micro models. For anyone that's tuning in that's a startup that's kind of wondering how they could sort of go about implementing this, is there a particular, I guess, large enough sample size or data set that you would recommend that they need to sort of start with for this to be really effective for them?
That's an awesome question, and I'm actually going to cover that in tomorrow's session for those who want to head along to that. But in short, there's two competing issues that we have to consider when we think about any kind of scientific problem. The first one is the law of small numbers, and that is just the general sense that if we have a very small data set, that we can extrapolate that out to the size of the population, and that turns out to not be true. There's a and depending on the type of problem that you're trying to solve. So generally they say start with a minimum of 50 items or rows, if you're going to train a model, but then that depends on the problems that you're going to solve. So if you start with 50, for example, and you go towards like a regression style problem where you're looking to predict an outcome or a value, you're going to need a larger set of data. And so then this starts to work towards this idea of the law of large numbers, which is the more samples we collect about a particular problem domain, the more likely that sample size will start to represent the average or the mean of the whole population. So just like the law of small numbers says that we can't just simply say, I've got 10, that must extrapolate out at scale. We also need to recognize that the more data we start to include, then the more likely we'll approach the median average of the population. So ideally we want to sweet spot somewhere where we can train a machine learning model where it's not what we call overfitted. So it's really good at the data it saw when it was trained, but it's not very good at generalizing its recommendations or kind of predictions when it sees data it hasn't seen. Or versus underfitting where we don't provide it enough information, it's just too generalized to be useful. That's a really great point.
Sure. We've got a question submitted from Jody Granger who says, great presentation, thanks. What is the most exciting use case next for you?
What is the most exciting use case next? Was that the question?
Yeah. I guess what you spoke about a couple of use cases. Are there any in particular that you think are really exciting sort of implementations that startups could look at?
Yeah, I mean, if I start to think about what's coming next, which is really interesting, I think traditionally when text analysis came about, we largely leveraged the state of the art at that time was this idea called term frequency inverse document frequency, which essentially just means we look for the most infrequent words because they're more likely to be interesting. And that created a lot of the search engines that we see today. What's really exciting is with deep learning, we're starting to build these models that are more based on semantic concepts. So the machine learning models are starting to understand that the meaning of a word based on where it's located, can give you far stronger insights into the data than just simple like synonym filtering, right? Like if I see the word case or I see the word matter in a legal system, then I know that it's kind of the same. What's really interesting with these kind of what's called embeddings or word embeddings is you can start to understand the nature of a domain by all the words and where they're located and where they've been found. So I think that's really exciting because we move away from a literal ranking style, information retrieval model, and we move towards a semantic knowledge learning, model. And so rather than having to go tell me something about a document in the database, I can say, teach me about something I don't know based on a set of data that I've given you. I think that's going to change the game significantly, going forward.
Great. We've got another question. The next one is from David Lamont, who says, looking at overlaying big data sets and analyzing it as a base for public health policy development, any quick lessons for young players?
Yeah. So the first thing is the great thing about big data, right, is that you end up getting a far richer model. The problem with big data is that until you, kind of start small and kind of build it up, the training workload can be incredibly high. So the best thing you can do is you have to sample the original data set. You take a very, very large data set and you start to sample it based on known features. And I'll give you an example. So if we're looking at a very large data set of a particular column of data, which might be someone's blood pressure, what we want to do is look at the other columns that correlate to blood pressure, and we want to start to break them down into what are the discrete values in them. So for example, rather than randomly sampling or just sampling the top 10 or top 100 of those rows, what we can do is say, oh, I've noticed that out of all the states, there's only 3 primary states that people in this data set come from. So I'm going to intentionally choose one from each of those states, now with times the cardinality of one of those values I want. And so you can quickly reduce a very large data set into what we would call like a representative or canonical data set that has all the features enough for a model to learn from and train. It's not randomly sampled, and also like it provides enough of a cross section, that's meaningful. What you do then is you take that data set and you start doing model exploration. So you apply a bunch of different algorithms against it, produce a number of models, see how those models work, and if you find a model that works really great, that's your algorithm model pair. Now you can start to increase more data, right? And so, but you can do that knowing that you're probably not going to hit major either correlation issues or kind of, dimensionality reduction issues. So I always recommend do a really good sampling, do it very intentionally, use that to find the right algorithm and model pair, and then start to include the data after that.
Fantastic. Thank you, Jody and David, for great questions. And David, once again, thank you so much for a great presentation. I personally took away a lot from that, and I hope everyone listening did as well. Very excited to have Dave back tomorrow for another session. But in the meantime, we're going to jump over to our next session. Our next speaker is the co-founder and director of C-Mode Technologies, a medtech startup that helps doctors better predict and prevent strokes without any additional tests. Please join me in welcoming Sadaf Monajemi to share with us on AI in healthcare, empowering clinicians to see the unseen. Over to you, Sadaf.
Thank you very much, Rohit. Hi, everyone. Hope you're all doing well. I'm Sadaf, as Rohit mentioned. I'm the co-founder of C-Mode. We're all based in Melbourne. I don't know how many of you guys signing in today are based in Victoria, but hope you're all enjoying the newly found freedom that we all got. So to start, I think let me share my screen and go through the presentation. Just one sec. All right. So can you just confirm with me that you can see the presentation, Rohit?
Yep, all good to go.
Awesome. All right. Yeah, as I mentioned, my name is Sadaf. I'm the co-founder of C-Mode. And in this session today, I am going to talk about AI in healthcare and mainly trying to answer the question that I'm sure you have all heard a couple of times at least, that is AI going to replace doctors or not? So I'll share my thoughts, I'll share my perspective about this, and I'll try to dig deeper into two types of applications that I think AI can be helpful in healthcare and improving patient care. But before that, let me start with a short intro about myself and my background. So I'm coming from an academic background. I finished my PhD about 3 years ago, playing with machine learning models, medical images and medical signals, and basically enjoying life as much as a PhD student can enjoy. But during my PhD, I always had this thought in my mind that I don't want to stay in academia. I want to go to the industry and try to work on a problem that is real life. That the research that I do doesn't just stay in academia, doesn't just stay in our lab, and it can impact someone. After my PhD, I started C-Mode about 3 years ago with my co-founder Milad. Fast forward to now, we are a team of 16 now, based in Melbourne and Singapore. Our first product of analyzes vascular ultrasound images. I'll dig deeper into that and show you a demo as well. We just recently received the amazing news that our product got FDA approval, which is exciting and terrifying at the same time because we have the US market open now. And it's already commercialized in Singapore and Australia as well. With that, I guess let's dig deeper into the question of AI and whether it's going to replace doctors or not. And for that, I am going to start with medical imaging and ask the question about medical imaging. Did medical imaging replace doctors or not? So medical imaging was invented about 100 years ago. I'm sure that all of you guys have probably received medical images a couple of times. It can be ultrasound, CT scan, MRIs, X-rays, any type of medical imaging. What medical imaging is good at is that it can help us see inside the human body without the need to opening up the patient. And it can help doctors and clinicians detect and diagnose disease faster and earlier, which means that the patient would have a higher chance of survival. So going back about 100 years to the time where medical imaging was invented, we can imagine that we could have asked the same question at the time, that medical imaging is basically allowing everyone to see inside the human body. So is it going to replace doctors or not? And today we know as a fact that in no way it replaced doctors. If anything, it expanded their scope of work a lot. It created a new field, new expertise in medicine and healthcare. And it created the whole radiology field, which is huge today. So obviously, medical imaging didn't replace doctors. Now let's see if we can ask and answer the same question for AI. Is the new hype, is artificial intelligence is going to replace doctors or not? I think when we talk about AI in healthcare, you have probably all seen images and photos like this of like fully fledged robots as doctors who can diagnose everything, who can treat everything. And to be honest, to me, it can be more absurd than that. I think the heart and soul of healthcare and medicine is human. When every one of us get a disease, we are quite vulnerable, and what we want is empathy from another human being, especially our doctor, who believe that they know the most about the disease. They're the one who can come up with a treatment plan for us, and they're the ones who can help us get through this. And I think that's exactly the last time, the last place that you want to break the doctor-patient relationship and replace it with anything that is not human, whether it's a fully fledged robot like this, or replace it with an algorithm that can diagnose your disease and communicate it to you. That's not at all what I think we should be aiming for with AI, and it should be the exact opposite of that. I think one of the major areas that AI can help with is to actually help doctors connect with their patients. So for example, in the radiology field today, we know that doctors are cramped with time. The demand is 3 times higher than the supply, and it's only getting worse. But at the same time, we know that radiologists are spending 30 to 40% of their times just interpreting images, reporting, and transcribing numbers into paper worksheets, which is not at all patient-facing. It's not the time that your doctor is communicating your disease with you. It's the time that the doctor is spending probably in a dark room, going through images and writing numbers on a piece of paper. So I think this is especially one of the areas that AI can help with, to automate the workflow, to automate that image interpretation and reporting process so that it saves time for the clinician. It gives back the valuable time to them to connect with their patients. And this is, I think, one of the areas that AI can help with. So let's see how it can actually help. But before jumping to that, I'm sure that you're all quite familiar with machine learning. I don't want to, dig into like the differences between machine learning and deep learning, the different like machine learning methods and all of that. But I think it would be great if we can agree that, machine learning is not magic, is not going to solve all of the problems in the world. It's not going to diagnose and treat everything. And honestly, it doesn't, to me at least, doesn't look something like this. If you want to visualize it, it probably looks something more like this. It's definitely not as fancy, but it's closer to reality. And I'm gonna embarrass myself with a super short like summary of what machine learning is. Again, don't want to dig into like differences between machine learning methods, but in general, what machine learning does is that it learns based on experience. So for example, in the case of medical imaging, if you pass thousands, say 1,000 images to a machine learning model and say that in half of these images, the patient got a stroke, in the other half it didn't, what it tries to do is to look at those images, find the common features, common patterns in those images, and try to see if it can differentiate new data coming in based on that. So yeah, I think regardless of the visualization and whether it looks fancy or not, it would be great if algorithms like these can help us free up some of the time from the clinician and give them back the time to connect with their patients. And in the rest of this presentation, I will focus on 2 use cases of machine learning algorithms in healthcare. Well, both of them are focused in the stroke domain because, well, at CMOD, we're working on a stroke, and that's the area in medicine that I'm more familiar with. But definitely the applications of machine learning is not just limited to stroke. So let's dive a bit deeper into a stroke and see how it actually happens and how machine learning algorithms can help with diagnosis and treatment planning for stroke patients. So ischemic stroke occurs where plaques, blockages in these blood vessels form. And when these plaques rupture, they can block the blood vessel, the blood flow to the brain, which causes the stroke for the patient then. Talking a bit about the statistics of stroke, we know that every 2 seconds as we speak, someone gets a stroke. Every 6 seconds, someone dies of a stroke. And unfortunately, every stroke patient has 50% chance of death or disability. But among all of these sad statistics, there is this piece of good news that 80% of strokes are preventable if we have the right tools to predict them. For example, if we can predict that the patient is going to have a stroke, the doctors can do a surgery and take the plaque out. But the problem is that while the stroke patients go under a lot of imaging and scans, the way that we analyze these images today is quite rudimentary. And we are missing critical risk factors from these images that are crucial for prevention and prediction of a stroke. So one of the imaging modalities that stroke patients received are ultrasound images. So if I go into a hospital as a stroke patient, one of the scans is ultrasound scan of my carotid artery. Carotid arteries are the main arteries supplying blood to the brain. So the doctor does the scan. The process usually is that they will take 50 to 100 images from different sections of that blood vessel, and then they have to go sit behind the computer, interpret all of those images, and transcribe and report them in paper worksheets similar to what you're seeing on the screen now. Actually, all of those 3 reports are real reports. They're from real patients from leading hospitals in Singapore and Australia. And I think just looking at those reports, we can see that, well, clearly it doesn't look like something from the 21st century. It looks quite old. And we can see that the reports look quite different between hospitals to hospitals, or even between different clinicians in the same hospital reporting those cases. So it's quite subjective. Coming back to the workflow again, as I said, for every patient, the doctor has to go through 50 to 100 images. They usually look at 10 to 15 of scans similar to this every day, which means that every day they have to go through 500 to 1500 images. And for each of those reports, they have to spend somewhere between 10 to 20 minutes on them. So it's quite clear that it's quite a time-consuming process. It, by nature, can be very error-prone because you're looking at thousands of images every day. And we know as a fact that error rates of 20% are the norm in the radiology field. So that's one of the areas that I think AI can help in the healthcare domain. And that's one of the questions, one of the problems that we try to solve and answer in CMO. So let me show you a quick demo video of our product. It's called AVA, short for Augmented Vascular Analysis. And the idea of that is, to automate that reporting process for the clinician. They should get the report, they should have the report ready before they sign into the computer, and they just need to review it, which would be a 1 to 2 minute process instead of the 10-20 minutes process that they have to go through right now. So showing you the quick demo, AVA is 100% web-based. Everything is actually hosted on AWS. We're on an AWS conference. And the way that it works is that the clinician logs in, they see all of the cases, for example, that they have completed all of the scans that they did for that day. They just download the report and the results. And as you can see, our application has gone through all of those images one by one. It has detected the relevant clinical findings, does segmentation, classification, all of that, and populate the report for them. And they can just easily click on any piece of information in that report and just double check it against the image, against the source image for that. They can make any changes, and at the end, when they were happy with the report, they can just download it as a PDF, whether they want to pass it to the patient or to another clinician to review those results. So everything you saw in the demo was real time. I think the duration of the video is about a minute. And it's, again, like one of the areas that I think machine learning can help reducing that 10-20 minutes error-prone process and automating it, reducing the time to 1 to 2 minutes for the clinician to just review the results. But let's see if machine learning can go beyond that as well, can go beyond, speeding up the workflow, speeding up the current process and reducing error, and help us detect risk factors, help us detect hidden information from the medical images. Again, focusing on an example in the stroke domain, as I said, stroke happens because of these blockages, these plaques in the blood vessel. Now, one of the critical risk factors for the clinician is to pick up the composition of these plaques, because different composition can create different risk level for the patient to getting a stroke. So, for example, one of the features that are interested to look at is called intraplaque hemorrhage. And basically what it means is that there is block inside that plaque, which increases the chance of rupture and the chance of a stroke for the patient. Now, picking that feature based on these noisy black and white images is quite difficult for the clinician. In fact, we did a clinical study in Singapore with 120 patients where two expert neuroradiologists were trying to classify these patients, trying to classify which of these plaques has intraplaque hemorrhage. And the accuracy of those clinicians ended up to be 60%. Which is obviously not great, but it wasn't surprising for them. They knew that it's something difficult for them to pick up based on these images. So we trained deep learning algorithms on them, and we reached 90% accuracy in detecting high-risk plaques. In fact, in the image that you're seeing, one of these plaques are high risk, one of them is low risk. I assume that it's quite difficult for you to pick up which one is which. To be honest, if I wanted to pick it up, it would be just like a coin toss, 50% chance. And it's not very far off for the clinicians as well. As I said, they had 60% accuracy, which shows us that, you know, there are hidden information in these images where human eye and human brain is not just the best tool that we can use for picking those features. And our deep learning algorithm could outperform the clinician with 90% accuracy. So these are the two examples that, you know, I think are use cases for AI. It can help us improve patient care and save the time for the clinician. Just to wrapping up the session and the talk, I definitely think that AI is not going to replace doctors. I can imagine, though, in future that clinicians who use AI would replace clinicians who don't. And the reason behind that is just that they have better tools. They can see more in images. They can see more information from their patient, which means that they can design better treatment plans for them. AI can be used to speed up the workflow, to prevent some of the errors that is just natural in the radiology and healthcare domain in general. And it can also go beyond that. It can help us see things that we just can't see with human eyes, not because it's related to the expertise of the clinician. It's just natural that, you know, human eye has not been built for looking at medical images, looking at a technology that was built for getting images from inside the human body. And yeah, that's it. Thank you everyone for joining the session. I hope it was helpful for you. I'd be more than happy to take any questions, or if you want to discuss further, just feel free to drop me an email later and we can discuss.
Fantastic. Thank you for another really insightful session, Sadaf. A couple of questions. So again, just a reminder for everyone that's tuning in live, there's a little live chat window that you'll find at the bottom of your screen. So if you have any questions for Sadaf or any of our speakers that come up, just a reminder to submit them via there, and we'll do our best to get to as many of them as possible. First question that I have for you is, how do you think clinicians would adopt AI products and technologies, and where do you think the challenges and the bottlenecks would be?
Great question. I think I was actually in another AI in healthcare webinar talking to one of the founders of medtech companies, and I think one of the great point that he mentioned is that AI in healthcare and AI software for clinicians, it actually shouldn't be about AI. It should be about the problems that it's solving. If it's solving a valid problem, it's something valuable. And then I think after that, it's up to the founders of the medical companies. It's up to the medtech companies to make sure that the product that they're building for the clinicians is actually useful. It can integrate into their workflow. It wouldn't change things for them. The UI and UX is designed in a way that matches their expectation, so that it can remove that burden from them, that they have to, I don't know, like pick up 1,000 new things to just be able to use a new software. I think it's quite common that sometimes we hear that doctors hate technology. I very strongly disagree with that. I think it's about the technology that they're using. So if you go to a hospital and look at the software, look at the technology that they're using, it looks something similar to, I don't know, like MS-DOS or software that we were using like 20 years ago. If I had to work with that technology today, I would hate technology as well. So I think one of the bottlenecks to make sure that we can actually bring AI software, bring machine learning technology into the hospital is making sure that we are designing in a way that it matches the expectation of technology today.
Fantastic. Next question is from Rachel S., who said, "This is amazing, Sadaf. Just wondering, and to your point that you just mentioned, just wondering how it will improve the outcomes for individual patients."
Yeah, that's a great point. I think for that, let me take a step back and talk about like the clinical guidelines that we have today. So the clinical guidelines, the way that they're designed is that they are based on a population where the clinical guideline, where the clinical experiment were conducted for. And it came basically from, averaging all of those data points and coming up with an average patient, which obviously doesn't match my profile. It doesn't match yours as well. It's just an average data point in there. Now, one of the areas that I think we can use data science, machine learning, and all of that is to make that personalized. My blood vessels, that their anatomy, their shape is different compared to yours, is different compared to everyone else. But the way that it's being managed in the clinical guideline today is just by measuring the size of my vessel and then coming up with a treatment plan. While there are actually a lot of other, risk factors, biomarkers that are based on each single individual, that if we can extract from those images, from the information that we have from the patient, we can then design the optimal treatment plan for that patient, instead of trying to fit them to that average data point in the clinical guideline. Sorry, Rohit, I think you're on mute.
Sorry, I am on mute. I feel like that's a phrase for 2020.
Yeah.
So next question I have for you is, what does the process of getting regulatory approval, FDA, for example, look like for an AI product?
Yeah, great question. So at the time that we started C-Mode, we obviously had very little information about the regulatory approval process. The whole machine learning AI software in medtech is quite new. So even the regulatory bodies had quite little understanding of how the regulatory process should be. But one thing that I found super helpful is that, well, obviously initially we were, for example, very afraid of talking to FDA because we are a small startup. You've always heard that getting FDA approval is super difficult. You're never going to make it, and you're going to die in the middle. But I think one thing that I learned over time was that the regulatory bodies are actually super responsive. So, for example, giving an example of FDA, FDA has a process where before going for getting regulatory approval, you can just have informal chats with them that, look, this is my idea, this is what I want to build. It doesn't have to be in a form of like any official documents that you have prepared or things like that. It would be just understanding that what is the problem that you're trying to solve? Are you looking at it in a scientific way? And it's similar to attending a scientific conference and just discussing with like your peers. which was super helpful for us. So I think I don't know if there are like any medtech founders in the session, but my advice would be to get involved with the regulatory bodies as soon as possible. Just discuss with them and they would help you understand the process. It's not actually as bad as we thought.
Fantastic. Next question that I have is from David Lamont, who says, does this not also provide an excellent basis for ongoing timely research and publication in the area, Sadaf?
Yeah, great question. So I'm also coming from academic background. My part of me is always, looking into publishing papers and excited about publishing papers. But that's a great point. So far in CMOD, for example, all of the research that we're doing, we are publishing those papers because it's a new field. There are a lot of understandings for everyone. But as you mentioned, David, as well, it's a great platform to just be able to look through all of those images that has been collected retrospectively, say over the past 10 years, and just trying to picking up these risk factors retrospectively and see if there are information in them that are missing today. And we can, for example, help predict the stroke for the patients. So one of the studies that we are doing right now is exactly that we look at retrospective data. We know that, for example, which of these patients end up with recurrent strokes, and we're trying to pick up that, without knowing that they got a stroke later, it can be detected and can be predict based on those images that they would get a stroke. So that's definitely that's an ongoing research, and it's a platform that everyone should use for just publishing it for the sake of everyone else.
I know that we've both kind of spoken about the challenges of being in lockdown prior to this session, but the next question is, I guess kind of timely given that consideration. How has COVID helped or hindered your business? And I guess what are your thoughts in the future in general, given how everything's kind of shaped out this year and how you think things will be like in the future?
Yeah, great point. I think it's a bit too soon to, be able to see all of the effects that COVID had in long term. But just talking about short term, for example, for us, we were running prospective clinical studies, which meant that we were recruiting patients and getting images from them prospectively, which COVID obviously slowed it down because the hospitals couldn't just work on research. They had to pause all of the research projects that they were doing. We were lucky that, a lot of our research was on retrospective data. So it was all on the data that was already collected, and it wasn't affecting us in that way. But I think more like general understanding, general impact of COVID for not just hospitals, for every, I guess, big institution is that, you need to go online. You can't just keep everything in your hospital. For example, one of the challenges that we had before is that every time every hospital you go to, they ask you that, oh, your software is hosted on cloud, can you do it on premise? And that's what I think one of the things that COVID actually helped, that, well, you don't want it to be on premise if your doctor is going to access it over internet from home. And I think that's actually one of the areas that COVID helped us as well.
Sorry, I'm on mute again. Time for one more question. So this is from Amir Pakar, who says, could there be a possibility of wrong decisions for outliers, guessing the authority sits with the practitioner who decides against the model?
100%, great point. And again, that's, I think, one of the areas that, we should think about when we ask the question that, is AI going to replace doctors? So at the end of the day, all of the things that we're doing, all of the information that we are extracting from those images is supposed to be interpreted by the clinician. I don't think that an AI model today or in the future should and can come up with a final diagnosis. But again, an area that it can help is that, if we can remove those like mundane routine work from the clinician, they would have the time to see the whole picture, look at all of the risk factors, and then decide about the optimal treatment for the patient. They would have the time to focus on more complex and trickier cases instead of just doing the mundane work. So at the end of the day, I 100% believe and agree that the decision is with the clinician because they see the whole picture. All we're doing is just giving them better tools, better information to be able to make that decision.
Sadaf, thank you for an extremely insightful presentation. I feel like we could end up talking to you about this all day, but we better leave things there. But thank you once again for sharing your valuable insights, and to everyone for joining us and for your questions as well to Sadaf. Next to share with us is Bradley Scott, who has spent the last 12 years of his career growing New Zealand tech companies, including MCOM, Pfizer, Xero, and now as Chief Operating Officer at Unique. Unique provides brands, developers, and creators a platform to create digital human experiences. Ladies and gentlemen, please join me in welcoming Bradley Scott to talk about the art of the possible, how AI has enabled new chats, a new class of experience with digital humans. Over to you.
Hi everyone, thanks for the intro. And so you don't have to stare at my ugly mug for too long, I'm going to share my screen to start us off. So, right, the art of the possible. So what I'm going to talk to you about today is a lot about our technology, which is relatively new, and what the notion of a digital human is and how Unique, our company, enables you to create experiences with digital humans. So firstly, I'm going to introduce myself. So the introduction said a little bit about that, but I'm Chief Operating Officer at Unique. And as Chief Operating Officer, I look after the technical teams, the product development, the platform teams, and all of our research initiatives in the area of AI and just other software development. If you want to get in touch, you can get in touch with both myself and Unique on Twitter. And I guess one of the benefits of being essentially on a webinar is that you can cheekily open a browser tab and read about some things. So if you're interested in reading more about Unique or digital humans generally, just pop the tab open and visit digitalhumans.com. Now, I guess the key thing or the key question that probably most people have if they haven't interacted with the digital human is what are they? What are you talking about? And how do I visualize something? So I've actually got a video that in testing works really well, and I'm fingers crossed everyone will be able to hear and see that. And that describes the notion of digital humans far better than I'll be able to articulate. So I'm just going to step forward and let that play for a little bit and then dive in deeper into some of the aspects that are raised in the introduction video. So here we go.
Digital humans are AI-powered, lifelike virtual beings that offer the best of both AI and human conversation. Today, they exist in both the physical world and online, where they can serve virtually infinite numbers of customers at once. So, what makes them unique? Digital humans interact using both verbal and non-verbal cues, like tone of voice and facial expressions, meaning they can recreate natural human interaction at scale. This makes for more engaging customer interactions that build trust, improve brand and customer experience, and provide around-the-clock support. And they do so using the most universal, time-tested, and in-demand interface that's ever existed, the human face.
So I'm pausing there to dive a bit deeper into some of the concepts and research behind what we're trying to achieve with digital humans, especially when it comes to customer service. Before I do that, I just want to, I guess, give a proviso for everyone. We are described as AI in a relatively rough and non-technical, imprecise way because people associate the personification of computers as humans as AI. And so I'm going to be talking more generally about digital humans as a concept. And then later on in the presentation, I'm actually going to be diving a bit deeper into some of the building blocks that goes into this technology. So, hold off the whole questions about, what is machine learning? What is this? What is that? Because I'm just going to do an introduction about the value that can be created through digital humans to start with. And I wanted to start with and talk very briefly in some research that was published in the Harvard Business Review. And it was around the area of customer experience and brand loyalty. And you can Google this article and a series of related articles relating to this research if you Google HBR, the new science of customer emotions. But one of the snippets that stuck with me around this research was along the lines of, it said, our research across hundreds of brands and dozens of categories shows that the most effective way to maximize customer value is to move beyond mere customer satisfaction and connect with customers at an emotional level, tapping into fundamental motivations and fulfilling deep, often unspoken emotional needs. And I wanted to explore this concept a little bit and how people have gone about trying to achieve this without the use of digital humans, for example, and other arenas, and then bring it back to digital humans about how digital humans help to kind of pursue that connection that people feel and customers can feel to a brand that generates brand loyalty. And so some of the examples that I wanted to highlight are shown on the slide. And there's lots of examples of enterprises investing significant sums to create brand ambassadors and creating a personality as part of that brand. And one of my favorite examples is the one on the very left here, which is the Geico Gecko. Now, probably not as familiar to people outside of the USA, but anyone that's spent any time living in the USA or even watching any degree of like TV and TV out of the USA, you'll probably recognize Martin. Martin's actually the name of the gecko. That's a good trivia answer for anyone that goes to pub quiz. But Martin the gecko has been a star of Geico's advertising for decades now. And all through that time, Geico has really invested a lot behind Martin the gecko. So Martin's famous for this phrase, 15 minutes could save you 15% or more on car insurance. And Geico spends over $1 billion a year in marketing. So I mentioned that just to demonstrate the amount of value that enterprises place in creating these memorable brands and the payoffs that they think that they're getting from it. And to give you an example of Martin and the Geico Gecko, for those who aren't familiar, I just wanted to play one of the Geico ads from a couple of decades ago. The video is a little bit grainy, but it doesn't take away from what I think some of the humor of it anyway. So I'll just...
Hey, Bradley. Hey, Bradley,
Yes.
Sorry, it's Colette here. We can't actually see your screen. I thought I might just flag it for you.
Okay. Well, let me stop sharing and sort that out. Is that better?
No, it's still your beautiful face though, so.
That's not a good sign. Okay. Let's try now. Showing a different window.
Looks like it's coming through okay on my side.
Okay. Cool. Well, sorry about that. And you would have missed the video too, which is kind of unfortunate. So just stepping back a couple of slides just to highlight a couple of things that you might have missed. So firstly, the contact details. So at Bradley Scott and at Unique AI, which is the Twitter handles, and digitalhumans.com, which is the URL. I'll skip over this video, you would have heard the audio. And I was focusing on this slide here around the quote from Harvard Business Review. So as I said, the HBR article is the new science of customer emotions. The character on the left is the Geico Gecko here. And so hopefully now you'll be able to see the video that I show about Martin. And we'll go from there, hopefully with the benefit of the screen share from now on. If there's any other glitches, just yell out, because can't necessarily see what you're seeing. Certainly from my perspective, it looked like the screen share was capturing the white window. So here we go with Martin here.
So word's getting out that Geico can help people save in even more ways. On motorcycle insurance, RV, camper, boat insurance. Nice work, everyone.
Well, it's easy for him. He's a cute little lizard. Gecko, actually. With all due respect, if I was tiny and green and had a British accent, I'd have more folks paying attention to me, too. I mean, save money. Pip, pip, cheerio.
British? I thought you were Australian.
Well, it's funny you should ask, because actually, I'm from...
Geico. 15 minutes could save you 15% or more on car insurance.
So word's getting out that...
So that's Martin the Gecko. And so there's an immense amount that Geico has put into building this brand, the Gecko. And when you go on the Geico website to try to get your 15% savings, spending 15 minutes on their website, you can see that Martin appears here also. But that's really the extent of it. You essentially get, as soon as you hit the digital experiences with Geico, the interaction with the Gecko kind of ends, and you're just in a website like any other website. You're just in a mobile app like any other app. And what we see is we see the opportunity and one use of digital humans, and a lot of our customers are interested in that use, is taking that brand and that persona and moving that into the digital interaction sphere as well. So imagine that you're going through the website and sharing your details to get your Geico auto insurance quote or your house quote, and Martin is talking you through that experience with the same personality that everyone has enjoyed through the ads that they've been watching in Geico. And you noticed in that ad, there's a whole lot of mysteries that they've built in. Like, no one actually knows where Martin's from. And Americans not being so good at picking up accents, are speculating that he's Aussie as opposed to someone else. And there's a few other quirks as well. And so this brand manifestation and taking the brand through the digital experiences, not just advertising, but into all of the transactional and self-service experiences, is one of the uses that our clients are making of digital humans. But there's others as well. And this, for example, is a fella called Sir John Kirwan. And anyone that follows rugby might recognize that he was a former All Black winger. He played 63 tests. He's famous for this try in the 1987 World Cup, where he basically ran through the whole Italian side. But not here to talk about rugby so much. But now what John Kirwan's doing with his time. So he is a spokesperson for mental health in New Zealand. He's written a couple of books on the topic. One of them is entitled All Blacks Don't Cry. Now, this is a photo of him doing a session as part of one of the organizations that he's co-founded called Mentor. And this is a session inside the Unique office, and it's a session around mental health and mental health wellness. And Mentor is a company that is specializing in that area and works with companies to try to increase the mental well-being of the employees of the companies they work with. And this is the Mentor application. So this is what they offer, and aside from the in-person sessions to introduce the topic, day to day they get people to use this application. And anyone that's close to the area of mental health might be familiar with the difficulty in attracting certain segments of the population to engage with this. So mental health's often or historically been quite a taboo subject. And so getting in particular people like myself, males, probably of my generation as well, to engage in this stuff is difficult. And so what Mentor have is the advantage of someone like John Kirwan, right? An All Black, a guy that most people that grew up in New Zealand and possibly other rugby fellows from around the world kind of respect. And so if you recall that photo of JK before, and then hold that in your mind's eye, and then look at this. This is digital John Kirwan. This is a digital human that we created for Mentor to essentially transport John Kirwan. There's only obviously one of the guy, and he can't be everywhere, but to transport him in the digital world. Because what Mentor wanted to do is use the brand and aura and the reputation of John Kirwan to help people engage with that application, to continually help them with mental health. And so that's another angle that our customers have tried to bring some of the physical world into the digital world and leverage that for the benefit of their customers. Zooming out for a bit and talking more generically, there's other advantages of digital humans compared to real human counterparts or other digital channels, for example. There's some that are obviously associated with digital content delivery generally, for example, no wait times. You can also scale infinitely, so you don't get bottlenecks on experts being available. Consistency is sometimes very important for customers, where especially in high compliance or sensitive representations, that brands might be wary about the types of answers that human staff give. Digital humans are obviously on the message all the time. There's also some softer and more unique aspects to talking to digital humans around, I guess, people's psychology. People will often not broach subjects with actual humans for fear of being judged, and mental health and sexual health are examples. Even things as seemingly benign as financial planning are topics that research have suggested people won't discuss with a real human, but quite happy to discuss with a bot or a digital human, for example. And so the other thing that's a bit unique about digital humans that you may have gathered, and we're going to get into, is the fact that they can be aware of the surroundings using digital faculties that are analogous to our human faculties like vision and hearing as well. And that's quite important in like a physical world. And you would have missed the video up front, but there's examples of digital humans who have created that are in physical store locations that you can go up and have a discussion with. So that's all well and good in talking about digital humans generally. But actually, what does Unique do and how do they make this all work? So the value proposition that we deliver as a company is we make it very, very easy to create these experiences. So we are a SaaS platform that essentially speeds your path to creating an experience. And we really provide two key things from a technology perspective. We've got web and mobile SDKs that allow you to build a digital human interaction into your website or a mobile phone or a physical kiosk experience. And we also provide a mechanism to connect in to whatever conversational AI platform you have a preference for. So we can integrate to all of the major players, many of which are shown on this slide. AWS Lex, for example, is a relevant one. And we do the hard bits in the middle. And if we're starting to get away from digital humans more generally and talking about the topics of AI, I'm going to kind of drill into specifically how the platform tends to solve for the hard bits in the middle, some of which is mentioned in those kind of 6 icons. And so drilling into those, really our platform is an aggregation of a whole lot of different assets and a whole lot of classes of technologies, that the outcome of which is making it easy for people that want to create digital human experiences to be able to do that. And we stand on the shoulders of giants, of innovations that have been made before us, and some of which we are adding to, that really get all assembled together to create this unique new digital experience. So advances in computer vision are really key to what we can do. So in particular, the ability to do that quite rapidly and in the cloud and make inferences from live streams. And so I'm not going to bore you with all of the examples of how computer vision has advanced recently, but we take advantage of that and being able to detect things around whether or not someone's coming up to talk to a digital human or they're just passing by, say, in a physical environment. Or, for example, we could have the ability to integrate into authentication systems or recognize aspects of an individual, such as age range that might be relevant to the course of the conversation. Speech recognition is obviously a key technology that is improving day by day that we take advantage of. So all of the mountains of data that is being generated, captured, and trained to create speech recognition models that can recognize different languages, different accents around the world, are things that we have bundled in to make digital humans able to speak multiple languages and understand multiple languages as well. Related to that is also the voice or the spoken word out of it. There's now increasingly sophisticated models that allow computers to generate much more realistic sounding human voices, or and so that is expanding both in languages supported as well as accents. We also have the ability to train completely new models for countries and dialects and accents of the world that aren't offered already or aren't able to be bought off the shelf. All of this, of course, is enabled on ability to get relatively large amounts of compute at economic cost and scaled up and down automatically. So platforms like AWS that we run our platform on is a very key ingredient to being able to kind of bring all of this together and make it seamless, so that none of our customers need to worry about managing any infrastructure around their digital humans. They turn on the service and they can throw tens of thousands, hundreds of thousands, or millions of users at it, and it just works like a breeze. The other area that we invest a huge amount in is creating human-like expressions. And so there's a range of techniques that we use, from motion capture techniques to AI techniques around animation of facial features like lips and mouth, eyebrow movements and head nods, and working out what the right emotes and ways of animating a face given any amount of text that we're asked to speak out. So making those decisions on the fly and having the digital humans really act as they ought to when they're instructed to speak or do something. And obviously the general state of the art of technology in terms of people's comforts and consuming SDKs and cloud services is another kind of enabling ingredient to our technology. What we essentially do is kind of bundle all of those disparate technologies together and allow you to design, develop, and deploy a digital human in minutes using a product that we call Creator. And you can go on our website and sign up for a trial and immediately within 5 minutes start with an experience of a digital human, and then start building upon that to make that more and more sophisticated. And we may have just a bit amount of time to watch one more Geico commercial, but I will skip it.
Geico's been saving people money on
as
car
much
insurance
as
for over 70 years.
I do love watching them. But the reason I was going to run you through that commercial is just to again emphasize that all of the getting started quickly and plugging in your conversational AI quickly is important. But for many of our customers, it is about that personality, that creator, and that brand. And one of the services that we do offer that our larger customers often take advantage of is actually creating characters that represent exactly their brand. And so there's a couple of ways that we do it that I won't elaborate on now. But aside from all of the AI and technology that goes into making the digital humans work functionally, there's also this very creative process that we bring to the equation for our customers as well, around creating exactly what these digital humans look and act like. And so to make sure that there's plenty of time for questions, I was going to pause there and open up.
Fantastic. Once again, thank you for a great session, Brad. Just a reminder again to everyone that's tuning in live, there is a little chat window that you can find at the bottom of your screen. So if you have any questions, please enter them, and we'll do our best to get to as many as possible. As someone who streamed a lot of sports from the US, I'm definitely familiar with a lot of the Geico ads, and highly recommend looking at some of those ads as well. But really curious from a business context. Especially I'm assuming that there are a lot of founders that are listening to the session and are part of the AI Conclave as well. And I guess whenever you're trying to implement a new solution that's very different or unique in the market, it can be really challenging. I guess I'm really curious from your perspective or experience with Unique, what are some of the barriers that you've had in taking this to market, and how have you sort of approached that or overcome that?
Yeah, sure. So I think we as a company have gone through a journey like many kind of startups do in maturing this. And we started off with a very small number of customers that wanted to invest in exploring this technology with us. And so we really started with quite a bespoke service, quite high touch, a high amount of services helping customers. And as we started to see patterns in what customers wanted, we started to be able to package that in a more repeatable form. And really what we are designing our product for and our pricing for, and what we're encouraging our customers to do is get in there, try the free trial, try some of the basic starter plans, and get out there and experiment with the hypothesis that you have about whether or not digital humans can create the value that you seek, because it is a new technology and we know a little bit, but there's lots out there that we don't yet understand either. And every use case in every industry is going to be slightly different as to whether or not digital humans are the best way to deliver that value. But our product proposition with Creator is giving people the ability to experiment and to get into this technology quickly and easily and cost effectively.
The next question, which I guess is related to that, is can the digital humans learn from failure? Are there particular mistakes, especially I guess if you're putting this in the hands of individuals being able to create their own sort of digital versions? Are you seeing kind of any, any lessons that are sort of being picked up from that process?
Yep. So I guess there's two aspects of that. One of them is aspects that we don't control, but I'll first answer the aspects that we do control. So one of the bits, or the main bit that we do is try to make the digital human emote appropriately for the context and the content that it's delivering. So to give you an example, if you're saying, "I'm sorry for your frustration," you don't want to say that with a big wide grin. And so we have a model that looks at various elements of the content in the context of what's being spoken and has basically a guess at the way to emote that. But we realize that some customers want control in certain scenarios where they want to know exactly how the digital human is going to emote. So we also have the ability to essentially prescribe in what way the digital human is going to deliver content, and that provides like a kind of balance between like control and then autonomy when, in terms of saving time. The second thing I would say is around the speech, or what is it the digital human can say or should say, and that's something that our system integrates into. And it really depends on like the type of conversational AI that our clients plug into. So some of those will be more unsupervised models that potentially could go off script. It's not something we generally recommend in customer service contexts. But in the supervised learning models, it's typically our customers will look at the conversations that have taken place and then deliberately improve and change essentially the conversational logic to accommodate that. So hopefully that somewhat answers the intent of the question.
Absolutely. I think we've got time for one more question. So questions from Lee Iraira. I'm hoping I'm saying your name correctly. This experience is so human-like. People must expect to talk to it very naturally. How do you cope with this mismatch in expectations versus reality and practical applications today?
Yep. So there's a degree of that, and we've learned some, I guess, UI best practices that help users interact appropriately with the digital human. It is getting closer and closer to the way that you or I would interact and discuss, but it's not exactly the same. So those UI practices that we've learned kind of help bridge that gap. That gap is closing though. So there's a lot of technology tailwinds, some of which I mentioned in the earlier slides, that essentially helping digital humans get closer and closer to a real human interaction. And then for the period of time where there's still a gap, then that's what we help our customers with in terms of like user interaction and user interface best practices to kind of help people bridge that delta.
Fantastic. And sadly, that is time, but thank you so much, Brad, for such a fascinating presentation. Everyone, please join me in thanking Bradley Scott, and excited to see where we go into the future with digital humans.
Thank you. It's a pleasure. Thanks for the invite, and thanks everyone for tuning in.
Thanks. Our next speaker was the founding Chief Executive Officer of Isotano and returned to this role in September 2018. He's a successful entrepreneur, angel and venture capital investor, and worked for over 10 years doing international cross-border mergers and acquisitions. Speaking today on computer vision and security surveillance, it is my great pleasure to introduce you to Matthew McFarlane. Over to you, Matt.
Oh, great. Thanks very much, Rohit. Really nice to connect with you and nice to have everybody on the channel. I'll share some slides and take you through a little bit about AI and video surveillance. It's a pretty interesting space, so I hope I can keep you connected. Let me just get this presentation up and running. All right. Great. So why am I talking about security video today and it's linked to AI? Well, there's a few facts that people may not be aware of about security video, which I think are really, really interesting. So first up, typical basic IP surveillance camera produces 1 megabit of data every second. A 300 camera installation, which is the type of camera installation you might see on a large office building or in a small part of a campus within a university, is producing 26 terabytes per day of data. And a single 4K camera can produce like 17 terabytes a day. This is an insanely huge amount of data. In fact, when you look at corporate networks, there's no larger source of data creation than their security surveillance networks, pretty much globally. And AI is uniquely suited to sifting through and analyzing this enormous mountain of data that comes out of the surveillance cameras on security networks. However, the rear view mirror is not particularly good because 98% of surveillance cameras are only used for recording and for scanning through an event after the event's happened. You will have seen on the television that the police are combing through surveillance footage to try and find the perpetrator of whatever crime might have taken place. But very, very seldom are these cameras used in real time. In fact, many of us who are on this connection today probably walked past 5 or 10 different surveillance cameras coming to work today, assuming you're not trapped at home, and none of those cameras would have been actively surveilled. In other words, there's no human sitting behind the camera seeing what's going on. You could literally be standing in front of a camera, waving your arms like this, and people are not going to spot you because it's just recording that stuff. Cameras are expanding massively all over the world. Next year, there's going to be 1 billion cameras dotting the planet. That's 1 for every 8 people on the planet. And the growth in surveillance camera operations is at 20% per annum. It's a massively growing market, whereas the poor old population is only growing at 1% per annum. So by 2033, there are going to be more cameras out there looking at us than there are people on the planet. How are these cameras used at the moment? Well, from a security context, security surveillance cameras are used to provide what they call in the industry situational awareness. That lets operators who are sitting in control rooms where these camera feeds come back to a centralized point create a bit of an understanding of what's going on across their surveilled site. So they know when dodgy characters are wandering about, they know when deliveries are being made, that sort of thing. It's also more actively used in the context of emergency management. So if an event has taken place, these control rooms leap into action to provide, again, the situational awareness and context, and allows more eyes to be placed on the site. So let's say that there's been an assault and somebody's running away from the scene, and this assault happens to be on a campus where there's broad security surveillance in place. The operators within the control room can monitor a number of cameras to see where the potential assailant is escaping through, and can then communicate through to the guards where they should be heading. However, the vast bulk of time in these security control rooms is actually spent on investigations. As I said, using the rear view mirror
to look at what's been recorded on surveillance footage and to analyze events that they've heard about because somebody reported, oh, there was some graffiti on this building from 2 days ago, or somebody got beaten up yesterday in the cafeteria, or whatever it might be. The investigations then have to kick off, and scanning through that footage is a very time-consuming and tedious task, but a very, very important task to try and find the people who did that. A lot of AI has been oriented towards supporting and improving that investigation aspect, and I'll talk a little bit about that during the presentation. The other security context is crowds and public order. So when a protest is forming or when a crowd is coming together, it's also something very interesting because it allows you to get kind of a precursor feel for when you need to get guards in place or go and diffuse a situation that's taking place in front of the cameras. Now, beyond security, it's interesting to think about surveillance cameras as part of the IoT phenomenon, you know, the Internet of Things movement. And these cameras are used for everything from environmental monitoring, such as, for example, if a fire has broken out in the forest, you can have cameras scanning across the treetops to detect whether some smoke is starting to arrive. Traffic management obviously is something that's for a long time been monitored through cameras and tracked, and even there are now AI systems in place to help with the timing of traffic lights and that sort of thing. Air quality, so surveillance cameras are very good at monitoring whether visibility is strong or poor. And waste management, some of you may not know this, but there's cameras fitted on many, oops, excuse me, it shouldn't have happened. There are cameras actually fitted on many garbage trucks as they drive around to determine the level of usage of bins and whether they're too full and that sort of thing. And even in the last 6 or 9 months, as COVID has really hit globally, what we've seen is surveillance cameras being used increasingly for public health and COVID-related matters. So AI systems have been extremely quickly adapted to do face mask detection, to identify whether staff are arriving in the offices without a face mask on or loitering about, or even just people on the street. To measure social distancing and identify if people are standing too close together or if crowds have formed in some way, to count and determine occupancy levels within buildings or facilities to say, well, look, that's clearly got more people in it than what it's been rated for. We should send somebody out to disperse that crowd within that building. And with thermal cameras, you can measure temperature, not particularly accurately, but you can certainly find if somebody's got a raging fever. And again, AI systems have been adapted in the past 6 or 9 months to be very, very good at high throughput temperature screening activities. So let's talk a little bit about AI learning and how that takes place, particularly in the video surveillance and motion aspect. So there's a couple of main ways that AI learning takes place. One is referred to as supervised learning. And this approach is where you are effectively training a system based upon a data set. So you want as much data as humanly possible. You've probably read about this with Facebook and Microsoft and Google, all very, very active in this space, where you are trying to train a system to, identify the difference between, say, a dog and a cat. And the more examples you can feed it, particularly when you're using motion video and there's various different angles and the resolution can be quite low, the more examples you can get it through to the system, the better it gets at learning and being able to predict the results of particular images being put in front of it. The main usage of this is things like object detection or image recognition or even behavioral movement. And sample applications, there's many companies trying to do gun detection. Active shooters is a very, very big challenge in the United States. And one you will have read a lot about is facial recognition, where you're identifying faces. Now, identifying faces, facial recognition for, a still image where, a photo has been taken and someone's, quite close to the camera, relatively simple. When somebody's quite distant from the camera and at a strange angle and it's a video feed, it can be way more challenging. Another approach to AI learning, which is less well known, is unsupervised learning. This is where algorithms are used and the system is provided data, but it is not given examples of an expected result. It's simply asked to find patterns and create its own expectation of what's going to happen in the future based upon the data that it's been fed. So examples of that are systems that find clusters of disease outbreaks and anomaly detection, which is the space that Isotana is involved in. So looking at AI for computer vision, the most common approach used by most companies out there in the world is supervised deep learning. This uses training data sets, and a lot of these data sets are publicly available, so you can actually hit the ground running with an enormous amount of pre-trained data. For example, the identification of the make and model of cars is something you can download from the internet for free and start to identify cars with your surveillance camera mounted in the front of your house to see who's pulling into your driveway if you really feel in the mood. The big advantages of this supervised deep learning approach is that it finds patterns and objects really, really accurately. It has quite, very, very good results. We're talking about 85% plus accuracy. However, the main challenges are that you do require an enormous amount of training data. You will very often miss things. And from a processing perspective, it's extremely processor intensive. So that can result in enormous bills or very, very expensive equipment. As an example, if you wanted to implement a facial recognition system, let's say you owned a casino and you had, say, 40 cameras around the perimeter of your casino, and you wanted to identify high stakes gamblers who might be coming in, or people who have said they want to be on the no gamble list by their facial characteristics as they're coming into the building. Those 40 cameras would require a server that will cost you approximately 60,000 Australian dollars. It requires so much processing to analyze this, and you'll still have a 10 to 15 second delay between when the person walks into the facility and when you get the alert that face has been matched. So there are better systems obviously out there. There's examples where it will run more quickly, but that's typically what we are seeing in the market in the facial rec space. The other big aspect to consider when you are training a system is that human bias has already been embedded in this. And this is one of the reasons that in the US, there's a number of jurisdictions where they have completely banned facial recognition because people of color in particular are very poorly identified using facial rec technologies. And a bunch of the results from this are oriented around human bias. So for example, people wearing a hoodie are just wearing a hoodie, but it so happens that a lot of them in the past might have been incremented towards doing nefarious acts, and the system thinks, oh, he's got a hoodie on, he's more dangerous, when really that shouldn't be the case at all. So some sample applications, I've already mentioned this: facial recognition, gun detection. Left bags is a big one in airports. So when somebody leaves a bag and wanders away from it, it's quite a challenging thing to do with motion video. Behavioral analysis, and that goes all the way from threatening movements where people are waving their arms around, or etc. And I'll take you through some examples of that with Isotana, through to facial characteristics. So in China, for example, they're actually measuring the happiness of the population based upon analyzing their facial features using surveillance cameras. And the example at the bottom, which is Isotana, I'll take you through more details of that, is in the anomaly detection space. And anomaly detection is quite different from the other applications because it's kind of, from a programming language perspective, it's saying if else. If something is different to what you normally see, then tell me about it. Whereas most of the applications that are out there are what we call rules-based systems, where they say if then, if this matches this, then give me an alert. So let's talk a little bit about Isotana's approach quickly. I won't talk a long time about this. This is a sample of a university campus, people wandering about. This is a mock-up of how Isotana might see this particular scene. So Isotana tracks pixels. It doesn't identify people or dogs or cats. It understands whereabouts within the scene the movement's taking place, understands the direction of the movement, the density of the pixels, and it also creates a model by time of day. So at 2 o'clock in the morning, obviously you wouldn't expect to see this many people wandering around, so that would almost certainly come up as an anomaly. At the same time, if somebody jumped into the garden at the bottom right of this scene, it would pick that up as an anomaly. Isotana does this training over 2 weeks, so it spends 2 weeks understanding typical expected movement patterns. Even if there are unusual things within those 2 weeks, they tend to get smoothed out over the course of the 2-week period. And then having completed that learning phase, it goes into monitoring mode. it keeps updating. So every single day, the system is improving its view of what's gone on in the scene. It actually drops the first day and learns the 15th day. So you have a rolling 2-week expected movement pattern for Isotana. It's very good in systems where you've got predictable movement taking place at normal times of the day regularly. A great example of that is in the prison context, and I'll show you some videos of that shortly, but prisons are a great case study for us. A less good example is, say, in the stadium where you might have a Mariah Carey concert on a Tuesday night and there's been nothing at the stadium for the last 2 Tuesday nights. You're going to find that all of the cameras light up for Isotana. So what do we do? Well, we do unsupervised learning. You don't need lots of training data. In fact, our systems are up and running within as I said, 2 weeks. They start reporting anomalies. The system is highly customized, so it learns for each individual camera. Other systems, you might come along and say, I've got a pre-trained training set. They'll start identifying things on this camera. For Isotana, actually, it has to take the time to understand the context of that individual camera. It's not biased by race, gender, or any other criteria. It's purely looking at pixels, and pixels are not something that you can be biased about. And one of the things we've developed over the 10 years we've been around is this black screen approach to reporting these anomalies or unusual events. We start with a screen where there's nothing showing, and then as events take place, they pop up on the screen and you can react to them. It catches the eyes of the operators and it draws their attention. It empowers human judgment, so it's an AI system oriented around enhancing human decision-making, not replacing human decision-making. And because we're reporting exceptions and we're not matching to particular rules, we're not looking for specific events, we will pick up a literally infinite number of potential events. It's existing systems which use rules-based are very much constrained by human imagination, whereas Isotana will pick up things that you would never imagine to be picked up, and it does create quite some fun and a few laughs in the office, the types of things that we pick up every week with our clients. However, because the system is a little bit fuzzy, we tend to only have a detection rate of maybe 80%. So it's not as accurate as what you might have when you have a very rules-based system, which might only pick up 1 or 2 or 3 alerts per camera per day, whereas our system's picking up 40 or 50 alerts per day. And it's simply saying, here's the 1 or 2% of unusual movement that's taken place that we want you to focus on, Mr. Operator. What this does is it allows security operations centers to move towards real-time operations in a measurable manner. So where are we going in terms of our roadmap? Well, we are currently at the stage of anomaly detection over on the left there. Anomaly detection is kind of for us is the next stage in movement detection. So surveillance cameras, they all come shipped with movement detection these days. Even the cameras that you might install on your front door have movement detection on them. Movement detection across a broad network will remove about 40% of surveilled time. In other words, 40% of the time on the average camera, there's no movement taking place. When we apply anomaly detection, we get that right down to 2 or 3%. So you've got a much smaller stream of data coming out of those cameras, which you feel is interesting and worth further analysis. Using tools such as NVIDIA's DeepStream tool, we want to build an integrated platform, which we call Isotana Motion Intelligence, which kind of combines motion detection with artificial intelligence and starts to do object detection, mapping and tagging, providing context for the operators, and throwing that up on the live wall so that they can make more informed decisions and more quickly decide whether something needs a reaction or not. So since we're a video surveillance company, I've got a few videos to show you. First up, this is an example of aggressive behavior. It's a great example that we use with customers where you want to get kind of the precursor events where a bit of argy-bargy is going on between staff members. You can see these guys gesticulating and threatening behavior. And you'll see this guy gets pushed around a bit. The system's very good at picking up people waving their arms about if they're reasonably close to the camera. If they're way in the distance, they may not pick that type of thing up. The next example is fall detection. So we're talking about a shopping center here, and escalators are a dangerous space for older people in shopping centers. And so this type of thing is very quickly picked up by the system. This is actually an example from a prison bakery, and if you watch the if you watch the door to the oven at the bottom left, it's about to be opened up by, I don't know, I guess he's the lead baker. But when he opens up the door, there's a burst of steam. And that burst of steam, even if it was smoke from a door or whatever, is picked up by the system as an anomaly. There's movement taking place in unusual areas. But perhaps more importantly for a prison, as the steam gets across the lens, you can see that the lens becomes obscured. Camera tampering or obscuring of cameras in prisons is a very serious matter. And that's the end of my presentation. I'll be very happy to take any questions.
Fantastic. Thank you for excuse me. Thank you for a great presentation, Matt. So just a reminder for everyone that's tuning in live, there's a little live chat window that you can find at the bottom of your screen if you have any questions for Matt. The first questions that I have for you are, what kind of AI ethical issues do you have in the surveillance industry?
Yeah, so there's a lot of ethical issues. People get very concerned about facial recognition and AI making decisions such as this person should be arrested because they conducted a crime in the past. The civil rights people are very much onto this, and it is definitely an issue within the industry. I talked about briefly the human bias that takes place with trained AI models. There's kind of very far extremes of different jurisdictions. So in China, anything goes, very similar sort of arrangements in Singapore, to be honest. If you look at Germany, if you are in a control room in Germany, you are not even allowed to look at live footage coming through unless you believe an event is taking place. So it's like the other extreme of privacy. So working out ways in which you are able to provide safety and security and monitoring in an ethical manner are actually quite challenging and a really interesting space to watch in this area in the future.
And who are the main leaders in the industry in terms of AI development in your mind?
Yeah, so probably the biggest company that's doing video analytics AI work is Briefcam. They're a company out of Israel, so spun out from the Israeli military training fields in the past. They were bought by Canon about 2 or 3 years ago. They've been very successful, particularly in the backwards-looking AI perspective. So being able to track what's happened on your site in the last, 28 days. They're very, very good in that aspect. They're used by a lot of law enforcement operations globally. There's a company called Clearview AI. Also, I think they started out in Israel as well, that does facial recognition. They're one of the industry leaders as well. There are many, many companies trying to deal with this problem because, as I said, there's 1 billion cameras going to be around next year, and people are looking to leverage that base of interesting data and infrastructure investment as well.
And again, kind of pulling this from a startup perspective, you spoke about the supervised versus unsupervised learning. Do you have particular use cases or I guess startups who are sort of looking to get into this space in terms of what sort of approach they take? Is there a particular recommendation that you would have from your perspective in terms of how they should make that judgment call for themselves?
No, I think for me, like I used to be a venture capital investor, so I'm used to talking to startups. For me, it's like listen to the customer. What does the customer really need? And then bring to bear the tools that make sense for that particular use case or requirement. Some customers don't know what they don't know. So, very often when we're selling to customers, we like to do a trial where they start to see what's the weird things that are happening in front of their surveillance network. And that's the aha wow moment where they go, oh my God, I've got to have this because I had no idea that this was happening in front of my cameras. But if you're a new startup and you're thinking about getting into this space, I would get really close to the customer, understand their requirements. And then a lot of the solutions that you require, you've got a huge leg up now in terms of off-the-shelf stuff. There's many companies have released developer toolkits to be able to analyze video surveillance. There's many conferences where this is published information. And I mentioned NVIDIA DeepStream, for example. Even just that one product gets you a huge leap forward. If I'd had that 10 years ago when we started Isotana, life would be very simple right now. So I do think it's a really exciting space. There's many opportunities, but with all startups, it's all about the customer. If you just get close to their requirements, then the tools that you need are much more available now than they ever were in the past.
Yeah. And obviously you showed some great examples of this in action. The next question comes from Amir Pakar, who says, have you come across examples where you can preempt incidents before they take place?
Yeah, absolutely. So we catch people loitering, for example, and people who are planning to break into some space. They will often like go across a garden or go into an area where they start to jimmy open a window. So before the alarm goes off for the window, you can actually see people trying to break in. When crowds are forming or people are jostling, this threatening behavior, if you can get a guard down there to diffuse the situation very rapidly, then that's a precursor event that we've prevented in the past. We actually had on one of the campuses where we operate, we had a stalker who was following an ex-girlfriend, and he'd brought a knife onto the campus with him, and we found him sort of going off into the bushes to watch her in her lecture theatre through the windows, and the system picked up this guy going into the bushes because it was unusual movement in front of that camera, and a guard went and effectively we caught that guy.
Wow. Next, I think we've got probably time for one more question. So Audrey says, sounds powerful to get some insights by installing cameras. How do you ensure the quality of the videos being recorded is up to standard for analytics, e.g. the lighting at 2 a.m. versus 2 p.m. may affect the results?
Yeah, so that's a really good question. So these days, almost all cameras that are being installed are IP cameras. If you've got very old cameras, say 10 years old, analog cameras, they can still go through an IP process and be digitized. Most cameras are coming out at 720p or 1020p resolution now, which is pretty good resolution if you're not doing facial recognition, right? There's a level of resolution that you require for some of the AI applications that is very, very high. For Isotana, we're quite fortunate. Movement tends to be something that is fairly chunky, and so any resolution from kind of 480, 720p upwards is fine for us. In fact, when you get to a 4K camera, that's a lot of processing for us because we're analyzing every pixel. So it's kind of horses for courses. Yes, if you are doing particularly detailed work, you probably want a very high resolution camera. That's going to cost you in terms of processing, and it's going to cost you on the camera front, as well as perhaps more importantly for the customer on the network front. They have to build a very, very capable network to manage those types of cameras and the traffic they produce.
Fantastic. Matt, I feel like we could talk all day, but we better leave it there. Thank you so much for that wonderful presentation. I think, again, I think everyone tuning in took a lot away from that. So thank you.
Thanks for having me. All the best. Thanks a lot. Bye-bye.
Thanks. So final question now before we move over to a break. Sorry. Next up is AWS's Oliver Klein. We'll deep dive with Intel's Pradeep Dubey. Pradeep is an Intel Senior Fellow and Director of the Parallel Computing Lab, a part of the Intel Labs organization at Intel Corporation. And he leads a team of top researchers focused on state-of-the-art research in parallel computing. Thanks to Pradeep and the team at Intel for your ongoing association and partnership with AWS. I will leave you now with Oliver and Pradeep, and we will see you back at 1 p.m. sharp to hear from Josh Shipman and Sarah Russell from Alula. Thank you, and look forward to welcoming you all back then.
Hi again, everyone. I'm Oliver Klein. I'm the lead architect for AWS in Asia Pacific, and welcome back to another deep dive episode of the Exec Leaders series. And I've been lucky enough to dive deeper with Pradeep Dubey, an Intel Senior Fellow and Director of the Parallel Computing Lab. Pradeep and his team has been working on defining the most effective architectures for AI and ML solutions. And we started the discussion by talking about just simple number crunching and how we bring that all the way to have AI make actual decisions.
So there's been this very natural division of labor for the last many decades, that computers focus on number crunching problems and humans focus on decision making problems. So far, computing, right, all computing infrastructures, that chips we build and the cloud services that Amazon offers, right, together, all we have primarily done is focus on a class of problem that number crunching problems, right? And computers have become such good number crunchers that human beings pretty much have given up on even the basic math. But when it comes to even basic decision making, we rely almost entirely on humans, right? So who do we hire, where do we go, what do we shop, or most of those things. So this division of labor is what is getting disrupted by AI. Now machines can actually make decisions. And actually I can make decisions sometimes better than most human beings make, right? And at least better than, not necessarily better than best, in some cases even that, but definitely better than average human being. And that certainly opens up a large class of problems where now computing can help, which were so far out of reach of computing. There happen to be areas of society where we actually need much better efficiency, right? Imagine teaching, imagine farming, right? These are areas a farmer is not necessarily more efficient now than they were 2 decades back. A teacher is not necessarily more efficient now. They're not generating or producing more Nobel laureates than they did 2 decades back. So how do we bring improvements in teaching and farming, which our society needs, right? Just to be able to feed enough for the people who will be on the planet, or just to be able to offer basic education to everyone on the planet, right? We need efficiency in these areas of human services, right? And machines can finally help. That's the most exciting thing, because AI can actually enable machine to not just be number crunchers, but to actually be making decisions and thereby solving more complex problems that so far were out of reach.
So Pradeep, how have we got to a place where AI can now help computers actually make decisions?
These problems, these decision-making problems, are largely learned by us humans by observing through our lifetime. That's how we get gray hair, right? By observing lots and lots of, and many times, most of the time, making mistakes, right? And learning, right? So we keep doing things and trying things and failing and keep learning from our mistakes. That's how I get better. So therefore, what you really need to be able to do what we do is have tons of experience, and not just your experience, but learn from other people's experience. That's what teachers do. They teach you from other people's experiences, right? Now we finally have enough digital data of behaviors, input, output of these complex systems, observance data, right? We also have enough compute and enough storage to be able to process this data to actually make good enough predictions real time. What we are trying to do here is learn from all to serve the one. That's what machines can do much better than anyone else, because we all ideally would love to learn from not just our mistake, but everyone's mistake all over the world. But we can't do that. Machines can do that because all machines are connected together thanks to internet, and they have infinite memory and increasingly more and more processing capacity. Therefore, they can learn from all observations anywhere and everywhere, and over time get better and better to serve that one specific instance where they need to make a decision.
Pradeep, I love your concept of learning from all to serve the one, but can you give us an example of this scaled technology-led decision making?
Let's look at one of the specific problems that where more and more people are born on this planet, right? And population is growing. We at least need to make sure that no one dies of hunger, right? That means at least the basic food, the crop yields for those cereal crops have to grow to keep up with the number of people who are on this planet and will be on this planet. And it's believed that by 2050, we would not have enough food just to be able to feed, unless we grow our crop yields of these cereal crops, we would not be able to feed our people at the current rate of growth of these crop yields. Now that's not a good thing. That's a very concerning thing, right? At 2050 is not that far off. So how do you model such a tough problem, right? It's not an easy problem. By just simply observing and looking at all kinds of data that we have on parameters and what happened to the crop yield that year when we had a certain set of parameters, and observing it over years and over large amount of such data, right? We can now sense pretty much everything, right? We can sense soil qualities, we can sense weather data, we can sense pollution parameters, we can sense pretty much everything. Now we start to correlate to see which ones of these are more important in terms of affecting the crop yield. By the way, this has to be complemented with first principles also. We also do know at the lowest level, at the micro level, we also do know how a plant grows, right? That growth has been figured out also looking at the most molecular level. So we try to combine these two approaches, right? Both inside out first principle simulations and outside in data driven simulations, to gain a deeper understanding of what precisely is the right thing to do. Even if we can make a difference of just 1 or 2% in these cereal crop yields, right, we can actually have enough to feed, just be able to feed basic the population that we'll have by this time frame. So we don't need big improvement, but the improvement is still significant enough that it's not going to happen on its own, and it's not happened on its own over last many decades. So this is where computing can solve such difficult problems, such tough problems, which have been looking for a solution, looking for efficiency improvement, such as in this specific case, crop yield.
Pradeep, you're right. Those seemingly small changes in crop yields can have a big impact on the food supply. So looking forward, what do you think is the next big evolution in AI that's going to help us tackle big issues that we no doubt going to face?
The hard problem we are trying to solve here is basically an optimization problem. Let's imagine a graph that goes up and down, right? Just like imagine stock market, right? It seems random, right? But how do you learn any such function, right, that is changing rapidly with time? The important thing to notice here is that you're not just trying to learn as one specific thing, you're trying to learn a family of things. So the growth in complexity is much better handled with quantum computing. So you're not just looking for me, you're looking for people like me, right? So whatever ups and downs make my face, right, it's not that specific one. You're looking for a family of such faces, right? That's by definition partly ill-defined problem, right? Because what do you mean by people like me, right? But it's also the most interesting problem. Okay, so therefore the difficulty of this problem is that it's a quote unquote very high dimensional, meaning it's a large number of dimensions to it, right? It's not just a matter of a single dimensional equation. So the dimensionality adds complexity to it. That means it requires large amount of compute, large amount of data. Okay, now where are these problems? Okay, these problems are primarily in first of all, they're everywhere, but where do we see the first application of it, right? The first application of this will happen in chemistry. Okay, chemistry meaning materials, right? So being able to design materials that nature never gave us, it's a huge opportunity, right? If we could do this, we could actually create the battery that doesn't exist today, right? The screen that doesn't exist today, the drug that doesn't exist today, right? Because nature only gave us certain class of materials, certain class of structure, right? If we can actually design these materials to our spec, which is almost like a nature-like power to us, we can design the material with the right properties that we are looking for, right? Of conductivity, of their touch and feel, of their electrical properties or physical properties. We can design them quote unquote to spec. Right? Now that's immensely powerful and immensely hard and will have big impact in terms of being able to design precisely the right compound, the right material. And this is where I personally think will be the first application of quantum computing, right? That solving such hard problems, so the drug discovery gets revolutionized.
Pradeep, I love your idea of designing drugs or medicines or other compounds to spec. I mean, that's just immensely powerful. But just changing direction here for a moment, like where do you think AI could help us potentially avoid or manage future pandemics a little bit better?
For a long time, we have tended to primarily focus on quote unquote the most likely scenarios, right? Or the quote unquote the bell shape of the curve, that bell part of the curve, right? And we have ignored what are called the long tail problems, right? The quote unquote what's been also referred to as black swan problems, meaning just that highly unlikely events. So what would it take for us to make sure that nothing is unexpected? Why? Because anomalies are super important, right? Flights are typically fine, but that one flight that suddenly disappears is a huge headline, right? A bridge that we take every day is perfectly fine. It's not a news headline. But when it all of a sudden collapses, when no one expected it to, is a news headline. But the important thing to note is that nothing, even though things, it seems like it happened all of a sudden, that's why it was a news headline, nothing really happens all of a sudden. Isn't that contradictory? The reason nothing really happens all of a sudden, that if you go analyze in all such cases where suddenly there was a bomb blast, suddenly a bridge collapsed, suddenly there was a flight disappeared, the reality is that there was a lot of information, lot of warning signs for it. A heart doesn't suddenly fail. Okay, anomalies were developing over months and months. You just never looked at it. We just never realized. We just never paid attention to it. We are focused on that central part of the bell curve, right? So our lesson learned and the general approach that we are applying now is that is this quote unquote the effectiveness of data, that the data is all good and you don't throw away any data, nothing's outlier. Analyze and keep them all. You're looking for a needle in the haystack, but every part of the haystack can be a needle tomorrow. So how do we learn and deal with those things that haven't happened yet? How do we deal with a virus attack that hasn't happened yet? How do we deal with a bridge before it collapses? And how do we deal proactively with undesired incident before it happens? Because nothing happens all of a sudden. Everything gives us a lot of warning. We just need technology and to be able to proactively monitoring and focusing us on those likely significant events of tomorrow.
A very interesting view on AI and machine learning and how it's useful in so many different areas and fields. And it's really interesting to see, like, we collect a lot more data points around the physical world out there. We now have the technology to actually make sense out of it and even predict things before they happen. Really interesting stuff. Now, unfortunately, that's all we got time for today. Thanks again for tuning in. Hope to see you next time. And until then, stay safe.
Oh, 1, 2, 3.
To those of you who had the pleasure of hearing from our speakers this morning, welcome back. And to those of you joining us for the afternoon sessions, a warm welcome to you. My name is Rohit Bhargava, and I'm part of the startup team at AWS and also host of the Startup Playbook podcast. A few bits of housekeeping before we get underway. So we encourage you to make use of the live chat. Please feel free to use it to introduce yourselves and share any useful information or resources, and to, of course, throw in any of your burning questions for our speakers today. We'll also be recording these sessions, and they'll be made available to all registered attendees on demand post-event. And finally, although we'll be keeping intros brief today, so we can get right into it, you can read up on all of our amazing speakers on the AI Conclave website being shared now in the chat for your convenience. It now gives me great pleasure to welcome Joshua Shipman and Sarah Russell, the co-founders and co-CEOs of AI software as a service company Elula, who will be speaking about how Elula's AI solution helps banking predict and reduce churn. Ladies and gentlemen, please join with me in welcoming Sarah and Josh.
Hi, we're really excited to be here today and share a bit about Elula and our software product. Before we jump into that, I know everyone is always interested in a bit of the founder story. So I thought I'd just take a minute and share a little bit about me and my background. Before starting Elula 4 years ago, I've spent really 20 years of my career working in financial services across a wide variety of roles. But everything I did involved data and analytics and using that information to drive change. I was very lucky in my last role before I jumped out and took the plunge to move into the startup world, to see many different AI organizations and vendors come and share what they did, and it really was the catalyst of starting Elula.
So a little bit about myself. I've been very fortunate to work in a mix of a career of both startups and big corporates. Sarah and I worked closely together in the bank before we set up the business, and we've been around for coming up to 4 years. It's really great to be with everybody here today. And I think in particular this session, because it was 3 years ago in 2017 that we were one of the Tech23 companies as well, pitching when it was just a handful of us employees in the Elula business. Today, we're a team of over 25, and our software products are used by quite a number of banks here in Australia. At Elula, we are a software company that primarily delivers machine learning software solutions. Our products are used across financial services, and today we're going to take you through our flagship product, which is called Sticky. And Sticky really helps banks and non-bank lenders to retain their customers. We focus very heavily in the home lending sector, being able to predict when a customer is going to externally refinance or property sell. So the bank can have that really proactive conversation with the customer long before the customer leaves. And that's the really critical point. We are very focused on delivering outcomes for our customers and making sure there's a big impact for them. We're solving a very critical problem for the banks. We're going to kick off with a short video. I'm going to hand to the guys now. We'll play the video, and then I'll speak and share more about what we do.
Understanding customers and how they really feel about us? That's been a pipe dream until now. Elula is using the power of AI to bring customer knowledge to the next level, and we believe it should be accessible to all. Welcome to Sticky. This is AI customer retention software that's business ready from day one. It works by running marathons to search out key behavior and identify which customers you should be engaging with. There's a lot of science behind all this. Let's start with our AI retention module. Here, Sticky looks beyond just one model. It divides the work across many different models, all actively competing against each other to provide the ultimate prediction. And if you dig deeper, you'll find even more models within these modules. This is customer understanding on a micro level. Sticky analyzes massive data sets of customers. Let's look at Lucia, Arnav, and Tom. They're all bank customers. Sticky identifies which one of them will be out the door soon, and it could be the result of any number of things. Sticky gives us a true understanding of why. It then uses explainable AI and mathematical optimization, so you can intervene to stop customers like Tom from leaving. Sticky lets you have the right conversation with the right customer at the right time. And all this insightful data is easily accessible through our Sticky UI or as an API. This is a true end-to-end retention solution powered by serious AI muscle. And it's just one way Alula keeps your business future-proof.
Okay, fantastic. So let's get up on screen some of these slides. Whoops. There we go. Okay, so look, customer retention is a huge problem for financial services. In fact, for lots of organizations. And it's been a problem that has been around for a very long time. And in this particular environment, it's magnified. And on any given normal year, about 700,000 home loan accounts churn per year across different organizations. So the bit of merry-go-round of money's moving around. And typically what you'll see is about $6 to $7 billion worth of loans will switch institutions every month. What's been fascinating about this particular year is that refinance has skyrocketed. In fact, in the month of April, it more than doubled. We were at $12 billion of home loans switching providers per month, $12 billion per month. In the month of May, $15 billion. In June, another 12. And it sort of stayed at that very, very high level. It's almost like everybody at home has got a new hobby of churning their home loan. And it's a huge issue for financial services providers, for lending providers. And in particular magnified in this environment because there's very little home loan growth as well. So retaining customers is more important than ever. But it's a really complicated problem to solve. Being able to identify which customer is going to churn and understand why they're going to leave, really complicated problem. Let's have a quick look at how banks solve for this today. So there are traditional approaches that are typically undertaken. And what we'll see is normally a bank will be very unaware that the customer is going to leave. That's actually kind of most banks' strategies of dealing with customers to date. They're sitting in the unaware bucket. And normally what that looks like is a customer decides to switch. They serve a discharge form on the bank and some poor, unfortunate soul in the contact center has to make this really difficult and awkward outbound call to a customer who's already decided that they're leaving. We then have another approach, another strategy that we see banks deploy, and this is a very reactive response. And normally what this looks like is a bunch of rules and very simple anecdotal rules that lead them to call very sort of filtered customers. And it might be something like, if a customer's fixed rate is expiring in the next 3 months, let's call all of those customers. In reality, those customers were not going to leave. A percentage of them were, and normally about 15 to 20% of those ones on that rule would leave, but about 80% of them aren't. Now, what that means is when the banks deploy that strategy of just a single rule, there are an awful lot of incorrect customers that are contacted, and that's a huge issue. The next sort of approach that we see is more traditional analytics. There might be a propensity to churn model, and normally that's sort of constrained by a few data sets, a bunch of rules added together. It could be tenure, it could be loan value, it could be a broker channel or whatever channel it came in from. It could be a recent statement print, a bunch of sort of anecdotal rules forming a score. Again, very similar problem occurs. We call in the wrong customers and a low volume of correct customers are interacted with. We set out 3.5 years ago to solve this problem and really help deliver much better personalized recommendations and interactions for the banks to proactively contact their customers. This graph here shows a little bit of an illustration on the uplift that a machine learning approach can deliver over a simple rules-based approach. And Sarah will step through this in a little bit more detail shortly, but you can see that machine learning way outperforms how a single rule would, what a single rule would deliver for the bank. And I think fundamentally the number one issue that you want to avoid here with these types of rules is waking this sleeping dog, is interacting with a customer that was never actually going to churn, and you're almost magnifying what is already a horrible problem to solve right now. What our product does is it really helps focus in on that customer that is going to leave so that the bank can have the right conversation at the right time.
Right, so let's dive in and unpack what Sticky actually is in a bit more detail. There's 3 key modules within the Sticky product. The first one is our data module, the second is a ranking engine, and the third is our explainable AI piece. So the data piece is really important, as I'm sure many of you on the call here today know that getting the data right and correct is just so fundamental for any machine learning or AI application. And we've invested a huge amount of time in here to identify thousands of different attributes of churn. The banks are just awash with so much data now, and with customers interacting, on web, apps, etc. There's just a huge amount of information that it's almost impossible for the human eye to pick out, which customers are at risk. So we take all of that data, engineer it, and turn it into these data features or churn attributes. So that's our first module of Sticky. The second module is our ranking engine, and this is the first suite of machine learning algorithms that we have in the solution. We run hundreds of models over that data, and what we're doing is, again, solving that very difficult problem of trying to identify who's going to churn. We produce a ranked list of customers, and we rank from the most sticky customers or the most loyal right through to the customers most likely to churn. And it's those customers at that top end of the list, the ones most likely to churn, where we provide our customers with retention leads so they can go out and make that proactive intervention. What's interesting and what I've sort of experienced in the past with a lot of data science teams is that it's almost where they stop. They've gone, right, we've produced a prediction, business, operator in the call center, run with that, go and retain that customer. That's really hard for someone that's sitting on the front line to then be able to pick up the phone and having an engaged and personal conversation with a customer when you're at that point. The machine learning outputs, the predictions, they're just not enough. They don't make it easy for someone to retain their customers. And that was why we then added a third module around explainable AI to the Sticky product. This is the piece that really enables us to get down to that mass personalization, identifying individual reasons why that prediction algorithms are identifying that customer will churn. We turn it into everyday language. It's very easy to understand, really clean and clear conversations for the person that's sitting in the contact center or perhaps a lender out in the branch, that they can go and contact that customer, have a very personal conversation about that customer's needs, whether it's refixing a product, maybe they actually need to review their loan structure, perhaps they're price sensitive and could do with a bit of a discount to retain them. But the explainable algorithm is really the piece that turns those predictions into a tangible action and outcome for the bank to go out and retain their customers. We're live now with quite a few banks, so as we speak, they will be out there making retention calls based off the leads that we're providing them today. Just want to loop back to the sort of the first slides that Josh showed, and where he talked about retention as a really big problem. It's certainly spiking at the moment. This is such an important and valuable solution for the banks. Not only do they want to be more proactive and have much more engaging and valuable conversations with their customers, it also goes straight to the bottom line as well. Each home loan customer that they can save will deliver, on average, $2,500 in profit per annum.
So, look, one of the questions that we often get asked is a piece about the team, and I'm going to preempt a little bit of that. So, as we said, about 3.5 years ago, we set out to build this software product and really help organizations take advantage of business-ready machine learning software that solves these critical problems, and this particular one of customer retention, and do so in a really accelerated time frame. The time to value with the product is exceptionally fast. We can have a bank live and operational within 10 to 12 weeks of the data being received into the product. And that includes all of the data engineering, centralizing the data, transforming it, training up the sticky products for the banks to make that outbound call. And if you think about it from the customer's perspective, it's also exactly what the customer wants. The customer wants really good service from the bank. All of us here today, anecdotally, whether we've experienced it ourselves or heard about it from one of our friends or family, we've all been in front of the message, oh, my bank, they're just so useless. They didn't contact me for this, or they didn't contact me for that. And in this particular day and age, this abundance of data and machine learning ability allows us to really deliver the services that customers and our customer's customer wants. A little bit about our team and culture at Alula. We're really passionate about this. I think the fundamental success of our company is our team, our fantastic team of data engineers, data scientists, software engineers, and this ability to fuse not just data science, but technology and business acumen. For some of you today listening in will have heard us speak before and know that we are big Amazon Web Services partners. Not only are we a customer of AWS, but 100% of our product operates on AWS, and our team are very passionate about that and the way that this works. And so the question that we often get asked is, hey, what does it look like to work at Alula? Can I join this team? And my offer would be absolutely drop me or Sarah an email, and please do reach out to us if that's a career path and something that you're sort of looking to explore. We wanted to make sure that we left plenty of time for questions, because I think that's really the exciting part that always happens. So we'll hand to Rohit, who I think is going to moderate some of those, and I might actually stop sharing on here so that you guys can just get our picture back. Not that I'm much to look at, but we'll get us back on screen, and over to Rohit to help with some of those questions.
Fantastic. Thank you once again for a great session, and a reminder to everyone that is tuning in live that there is a little live chat window at the bottom of your screen. So if you have any questions for Josh and Sarah, please submit them, and we'll do our best to get to as many questions as possible. Just picking up on that last point in terms of joining your team, and I assume that there's a lot of startups that are listening to the presentations and are part of AI Conclave as well. When you think about sort of building out your team, do you have any advice on how you should approach that from a data scientist and kind of engineering perspective, or anything that you can share in terms of how you've thought about building out your own team as well?
Let me take that one. Look, I think our approach is, everyone has strengths and weaknesses, and everyone might start out looking for that unicorn person, the person that's got, ticks every box, they've done this, they've done that, that person doesn't exist in reality. And particularly in the spaces that, we're all talking about here, we're really talking about some cutting edge things that we're doing. So you just can't find that person that ticks all those boxes. So what we try to do is go, right, well, what's the strengths that someone has? How can they fill in those particular gaps in our team? And we focus on maximizing the strengths that they have, playing to their advantages, and then we'll look to fill in those gaps with someone else that has strengths in another place where we need support. So really trying to build up quite a broad team.
I think the other piece that I would add on to that as well, certainly one of the things that we think of here is, it's around attitude, and I think this plays through. It's such an important part of a role, and even more important if you're a founder of a startup or you're looking to grow the team. You need people in your business that really have that can-do attitude. And I think that whilst both Sarah and I have had careers in a corporate, lots of people in corporate kind of don't have or can't make that jump into a startup. It is a very different world. So I'd say sometimes you can find some wonderful people from corporates, but also don't be overexcited by that. I think the fundamental thing is that attitude and that resilience, because it's a crazy roller coaster being in a startup, and you often are in that really difficult pit of it, and you want the people around you that are fighters and can dream big to push through all of that.
Yeah, absolutely. Attitude, resilience, and cultural fit are super important, especially at the early stages of your company. We've got a question submitted from Brian Doricott, who said, great to hear how you're helping the banks understand the data that they have available. Can you share any of the features that surprised you when it comes to customer retention?
I'll go. I'm happy to take that. Look, I think there's two parts to my answer. I think, in terms of the question, what features surprised us the most? I think what surprised me the most is that what you think will be an obvious feature is not. And it really doesn't deliver much insight. So the obvious things that you think will deliver lots of value might be, hey, it's a broker originated loan and it's going to churn somewhere between 2.5 years. Actually, yes, there will be a number of those that churn, but there's not that many. Okay, and the same with things like customers that are on a high rate or have a fixed rate expiring. I think the complicated thing about the problem that we're solving is that there isn't one silver bullet. There isn't. I wish there was, because it's just like a dog of a problem that we're solving here, and I really wish there was that. I think that the insightful thing is, the more features and the better quality features you have can move the dial. And that will change depending on the customer that we're working with. Some of the banks that are customers of ours are tier 1. Others are very small credit unions that have profession-based and they're regional. And so you have different types of customers. So different features work differently with each of those. And the strength of the product is the ability to use the library of all of those features and engineer it to your loan book.
Fantastic. Next question that we have is from David Lamont, who says, retention is vital, but attraction precedes it. Can you use the same approach for attraction as well?
Definitely similar approaches to that. The reason we've focused on retention rather than on the acquisition side of things at the moment is, one, it's a really big and important problem for the banks. It's also not a particularly sexy or exciting problem like in the first sort of instance. And the great thing about that is everyone tends to go after the big, sexy, exciting problems to solve. There was a big gap in this space, and at the moment, the level of growth that's happening in the market has been relatively low.
Yeah, I guess that's part of a broader question as well, especially in the industry that you work in banking and in fintechs in general. There is just so much opportunity that's out there that, oftentimes it can be really hard to understand what you should focus on. And again, from a founder perspective, that's often a challenge that a lot of early stage founders go through as well. Again, do you have any advice or kind of, can you talk a little bit about the approach that you took to kind of focus, to identify and focus on this specific area for Lula?
Sure. So, look, for us, I think there's for any founder out there looking at a business and thinking about it, you've got a perceived need and an actual need, and customers will pay for an actual need. So you want to identify who's going to put their hand in their pocket and pay for that business problem, and that's kind of part one, and that will quickly determine whether or not you have a business that you can operate on. And then the second part of it is, now, can I make that scale? Is this a repeatable problem? Because somebody might be prepared to pay for solving a very specific data science use case in their organization. And if you want to run a consulting company, well, go and do those things and pick up lots of those things and be all things to everyone. But if you're setting up a software company, you need to go, right, can this sticky product be used by many different industries, many different use cases? Obviously, this isn't only being used in home lending. It can be used in all different types of areas where there's large customer base. So can you bring this into an area that can scale and those types of things? And I think that when you're going out and identifying these needs, you've just got to listen to what people are telling you. It's certainly helped us a lot, having worked for so many years in the banking sector. You know what problems need to be solved. And then I think the final lens on that is going into an area where, you don't want to necessarily go into something where there's 2,500 vendors already in that space and it's flooded. You're a little bit late into market to solve that problem. So I think it's like the balance of all of those things.
Fantastic. Love that response. Once again, Josh and Sarah, thank you so much for your time and for sharing your insights. I'm sure our viewers got a lot from that session.
Pleasure.
Next to share with us is Dr. Michelle Perugini. Michelle founded her first AI business 10 years ago, which was acquired by Ernst & Young in 2015, and is now the co-founder and CEO of Precigen, which is an AI company that specializes in creating globally scalable image-based medical diagnostic products using its advanced AI platform. Speaking this afternoon on building globally scalable AI healthcare products, a case study in fertility, please make welcome Dr. Michelle Perugini.
Thanks so much, Rohit, and thanks so much for having me on the talking lineup today. It's really exciting. We're also one of the Tech23 winning alumni companies, and we work heavily with the AWS team and have heavily integrated their cloud services into our product base. So it's great to be here, and just a reminder to all the participants to think of lots of questions as I'm running through my slides. But what I really want to do today is talk about some of the challenges with building globally scalable AI products within the healthcare context, because it's a really unique industry. And then I'll do a bit of a spotlight case study on the fertility sector, where we've built a really interesting product for the IVF process. So Precigen is an AI healthcare company. We've got a global first mission and a focus on building scalable AI healthcare products to improve women's health globally. And Life Whisperer is our first product that uses artificial intelligence for embryo assessment during the IVF process. Why do we care about technology in the healthcare sector? It's a really unique industry in that the healthcare spending is completely unsustainable. We're living in a global population that's on average aging. The healthcare costs are becoming really high, and essentially what technology can do is help create efficiencies within the healthcare system, improve patient outcomes, improve efficiency in clinical processes and decisioning to the extent that we can reduce that healthcare spending. And in terms of the femtech sector in which we operate, it's a really interesting market. It's massively growing. It's around a $50 billion market, growing at a really high rate. And it's been underserved for a long time. A lot of reasons for that, which I won't go into today, but there are some really unique challenges that are very synergistic across different women's health application areas. And we've chosen to focus in women's health because our first product happens to be in the fertility sector, and there's a lot of synergies across those different other subsectors in the women's health space, including obstetrics and gynecology and female incident cancers. We think it's a really important area of research and development, and we're really keen to explore products in those spaces. So when we're talking about bringing technology to the healthcare sector, like artificial intelligence, technology is kind of the interface between the clinicians and the patients. Clinicians are the primary caregivers. They're obviously making critical decisions for their patients, but they're doing so in a really time-poor environment. And these are critical decisions. What technology can do is improve that clinical decisioning through clinical decision support tools, can improve efficiency and accuracy of diagnoses to the extent that it can drive better outcomes for patients, which is obviously what patients are looking for. And some of these technologies, if they're built for scale, can actually be a very low cost solution to help provide those better outcomes, and can actually increase the transparency between the clinician and the patient around the treatment of their particular conditions. So AI in healthcare is really interesting. The reason that it's become so popular as an industry is because the health economic returns are expected to be about 5-fold of the actual investment in that AI. So it's a really big return on investment in terms of those savings and efficiencies and better outcomes that can be achieved through using this type of technology within the healthcare context. And some of the ways that AI is currently being used is personalised medicine, for example, trawling through very large genetic data sets from different individuals and then personalising their treatment or care, or looking for markers of specific diseases or potential targets for different drug responses. That's being used heavily. Pharmaceutical industry is using AI heavily. There's a lot of companies emerging in the in silico drug discovery process. So instead of doing laboratory experimentation, we can now, within these computer and AI models, test in silico thousands or even millions of drug targets and become really efficient with the way that we kind of push those through that drug discovery pipeline. And the area that we're interested in is really in the diagnostic space. How can we use AI to take images of a particular, in our case, in the Life Whisperer context, of embryos of patients, and then help clinicians to make a better decision around the course of treatment during IVF. But there's many things that are holding back AI in healthcare, and most of it has to do with the limited scale of these AI products. AI products are not scaling in the way that traditional software is scaled. Healthcare is a global problem. It needs global solutions. It needs access to global data, which is very difficult in the healthcare context. And if these AI products are not built right from day one, the AI can be incredibly biased, brittle, and unreliable. And what we see is that many people focus, or companies focus, on building an AI prototype on a single institution's data. It might be a Stanford or a Mayo Clinic data set, very reputable data. But when they go to translate that out into clinical practice, it just doesn't work. It doesn't scale effectively. It needs to be retrained on the data of that institution, and then that is a very slow, unscalable process. So what's needed to build globally scalable AI products? I've kind of categorized this into two different parts. One is the globally diverse data, incredibly important to train the AI. If you're going to deliver it to global clinical environments, it needs to be trained on data that represents different patient demographics and different clinical settings. If it is not, it will not generalize to those different clinical environments. And by the same token, it's actually about getting the right data, not more data. So many believe in what we call the AI data fallacy, that more data means better AI. It's actually not the case. It's all about the quality, and it's all about the type and the construct of that data that's important. And often it's a case of less is more. And there's some key challenges. So having said that we need a globally diverse data set in order to train our AI to build an effective, scalable AI product, there's many challenges that prevent that happening within the healthcare context. Data privacy laws that make it difficult to move and centralize global data sets outside of the country of origin, which is typically what you would do if you were to train an AI. There's issues with respect to clinical collaboration. Data is locked up in these different individual clinical environments distributed globally. Not only can you not access them because of the data privacy laws, but many of those clinics are not willing or don't want to give away their data for free. There needs to be some sort of incentive for these clinical data contributors to really be incentivized on the outcomes of these products. And the third thing is data quality. There's a huge issue in terms of data quality within the clinical context due to clinical uncertainty and subjectivity. And even 1% of poor quality data can significantly impact on the accuracy and scalability of the AI that is built on that data. So it's a significant problem. And this is what we focused on in Preston. We've focused on developing an approach that is a paradigm shift in the way that scalable AI healthcare products are built. We have a global cloud platform that is hosted on the AWS service that allows us essentially to collaborate with clinics from all around the world and enable them to contribute their data locally without ever breaching data privacy laws. We then have a royalty-based incentive model. So any of our clinical data collaborators actually, that when they contribute their data, they get royalty incentive back for their contribution once those products are commercialized. And that's a really nice way of making them a collaborator to the AI build. They don't need to do any of the technical work, but they still receive or have the ability to maximize the value of the data that they're contributing. And then we have a federated learning approach. So it's a very unique algorithm that sits on our platform that instead of centralizing all the data to one spot and then training an AI, we can actually send our AI out to train on locally distributed data from all around the world that is housed on our local servers via our platform. And what that means is that we don't need to ever move or see the data, which overcomes those data privacy issues. And it actually, we've shown that it can improve the accuracy of the AI compared to centralizing. And then data cleaning is also really important. And we've got some unique ways of automatically detecting and removing poor quality clinical data that is hampering the ability of these AI products from an accuracy standpoint. So when we utilize this platform, it's essentially, there's 3 steps. We partner with clinics, they contribute data to the local servers via our clinical data portal. We then co-create the AI using that data and send out our federated AI training system to train on the data distributed globally. And then we deliver that algorithm as an actual product through our clinical cloud delivery system back into those clinics and many other clinics globally. So what I want to do now is just switch to talking about Life Whisperer, which is the first product that we have developed that demonstrates the scale of our platform and the ability to build products that can truly be put into any clinical environment globally. And as I mentioned, Life Whisperer is an AI assessment of embryo images that allows us to essentially pick which embryos have the highest chance of leading to a pregnancy during the IVF process. Fertility is a huge problem. globally. There's around 200 million infertile couples worldwide that rely on technologies like IVF in order to be able to get pregnant. It's, for the patient, extremely traumatic. It's a really stressful journey. It's financially crippling for many couples, and the success rates are incredibly low. So you can imagine the stress that that places on those families that are undergoing the treatment. And during the IVF process, what happens is eggs are extracted from the female. They're then fertilized in a culture dish with sperm, and they develop into embryos over a period of 5 days. And at that day 5 point, a single embryo needs to be selected for transfer back to the female in the hopes of creating a baby. And selecting the best embryo at that point is critical to a successful pregnancy outcome. But how it's done currently is through manual visual assessment by an embryologist down a microscope, is limited to what the eye can see, and is limited to a few macro level features of the embryo that they know to be predictive. Or they can use a genetic sequencing approach, which is highly risky, quite expensive for patients, and it's very invasive. It requires cutting out part of the developing embryo for genetic screening, and it's only looking at the genetic health of the embryo, not the likelihood of implantation. So what we have done is we've developed an AI that takes images that the clinics are already taking of the embryos that are in culture immediately prior to selecting an embryo for transfer. They drag and drop those images onto our web-based application, and within about 10 seconds, the AI analyzes those images and provides a score between 0 and 10 that relates to the quality of each of those embryos. And they use that to rank order the embryos for transfer or for freezing or whatever it is that they're doing with them after that point. Our AI has been built on tens of thousands of historical embryo images where we knew what the pregnancy outcomes were. It's been built collaboratively with and for global clinics on global clinical data, and it's learned the really generalized features that are associated with good and poor pregnancy outcomes. We're now approved in 60% of the global IVF markets, world markets, and we have initial users in 6 countries already. And of course, it's been extensively clinically tested. We've done an international study that showed 25% accuracy improvement comparable to the manual visual assessment, decrease in pregnancy of time to pregnancy of 15% on average for patients, which is huge. And actually this saves patients money because they don't need to go through as many repeat cycles. And for clinics, it can increase their revenue base through allowing them to be more efficient and service more high value first cycle customers and get patients pregnant quicker. The product, as I mentioned, is already out in market. We're seeing the first babies being born through having used Life Whisperer as the embryo assessment approach. It's really exciting. The feedback has been incredible, and it's a very strong value proposition both for the patients and the clinicians. It's really exciting, and I guess our ability to set new clinics up within minutes within these different countries really demonstrates the scale and breadth of the utility of this particular product, which is solving a global problem. And one of the other things I just wanted to talk to quickly with regard to scale is, one of the reasons that it's so important to build AI products that are scalable is so that they're accessible and affordable for patients in this context. So as you can imagine, developing a product like this is very costly. The regulatory approvals process and compliance issues are extensive within healthcare. And so if you can't deploy that product then globally at scale, it makes it very expensive for patients, and it can be cost prohibitive in many cases. And so with our approach, we've built this product that's truly scalable. We can set product clinics up in minutes anywhere in the world. It's a simple drag and drop assessment for them. There's no upfront costs. There's no hardware componentry to this. So there's no capital expenditure by the clinics. And it's a simple pay-per-use. So when the patient elects to use this service, it incurs a charge, which is either consumed by the clinic or the patient as an add-on cost to their treatment. So it's a very simple way of demonstrating the scale. And we aim to be, within the fertility sector, the leading AI product across the whole IVF process. So we already have a number of other applications in production by virtue of our platform. The second one is looking at non-invasive genetic assessment of embryos, which is really interesting. Just taking the images of embryos, we can actually see whether there's likely to be a serious genetic defect in those embryos without ever doing an invasive test. Which is really exciting. And then beyond this, we also have a number of other R&D and commercialisation projects planned for additional femtech sector products outside of the fertility sector. So I'm going to leave it there, and I'm really keen to answer any of your questions. I'll stop sharing my screen now and open it up. Thanks so much.
Perfect. Once again, thank you for such a great presentation, Michelle. That's been really insightful to hear some of the work that you're doing in the space. Just something that I wanted to pick on while we're waiting for questions to come in. So again, a reminder for all of you that are tuning in live, there's a live chat window at the bottom of your screen for any questions that you've got for Michelle. You mentioned, obviously in the healthcare sector, there are sort of significant large upfront costs that take place that potentially aren't, as prevalent in creating, say, a software as a service business. I guess from your perspective, what are some other sort of unique challenges with healthcare in respect to building sort of scalable technology? And I guess do you have any advice for any founders that are going through that process at the moment?
Yeah, I think there's many challenges within the healthcare sector. It's highly regulated, very compliance driven. And if you're looking at technology in the healthcare sector that utilises data, then obviously those data issues that I talked about in terms of data privacy are a prime concern. So there's a couple of things that I would say. What we've done is we've always tried to meet the highest stringency requirements that we're going to come up against in the world for data privacy and for regulation, because then what you do is you build the product from day one with those requirements in mind, such that once you've developed it, it's fit for purpose and fit for multiple markets. So I think that's what I say that's what I mean when I say we really have a global first approach. We take a global view of development of these products, understand the global marketplace, understand the requirements that we're going to need to meet, and then build the product to meet those requirements from day one, so that you're not having to rebuild, because it's a really expensive process to build and rebuild within the healthcare sector, and many companies fail trying that. So yeah.
Yeah, slightly different approach to launching an MVP and just getting something out the door.
Yeah.
We've got a question submitted from Priya, who says, how do you measure the ROI in AI-based healthcare products?
How do you measure the ROI?
Return on investment in AI-based healthcare products.
Oh, that's a really interesting question. I guess it depends on the context in which they're being deployed. So, with our product, the nice thing about it is there's no upfront. I mean, for us as a company, obviously we measure our ROI based on how long it takes us to develop the products and what spend goes into that versus the ongoing costs of delivery. And what I can say is that it's a pretty unique industry in that the upfront costs are quite high, and it takes a long time to get those products to market and actually developing revenue. However, once they are in market, the actual deployment and delivery of the products is quite inexpensive, so the margins are very high. So it's a little bit of a different model to a traditional SaaS-based kind of deployment. So, but for the actual customers, it's really important, because these individual clinics often, I guess one of the values of our type of solution that can be deployed in any clinic is that they don't have to develop it themselves, because for a small clinic that's not expert in developing technology like artificial intelligence, it would be a massive investment for them to do this just for the benefit of their own clinic. It's too small a marketplace to warrant the development of this type of product, which is kind of why I always harp on about the need to kind of develop this scalable model, because if you don't, then the cost for patients is just too great, because you need to be able to recoup those investment costs that you've had to develop the solutions with.
You mentioned earlier in your presentation the cost savings that are in place for the customer as well as for the clinics as well.
Oh, I actually am losing the audio on you, Rohit. I'm so sorry, I can't hear you very well.
Is this a little bit better?
Yeah.
Perfect. I was just mentioning that in your presentation, you spoke about how through your product, through Life Whisper, the end customer is saving money and the clinics are making more money as well, which seems like a win-win situation. I'm just really curious to know if what has the clinical adoption been like for the product, and do clinicians see this as competitive to their own skills?
Yeah, the clinical adoption's been quite good. Of course, when you're developing technology for a conservative kind of industry sector that's highly scientific and clinical, it is difficult on the adoption front. However, I think the industry understands the value of the technologies that are being developed in this space, and I think they understand the limitations of what they can do just visualizing an embryo down a microscope, for example. So they're quite amenable to approaches that help them. But the important thing is they need to be incentivized to care, right? And it's not just about the money, but it's about the fact that they're treating these patients. They want to be involved in the actual development of the AI because that's the way that they trust it. So when we came up with our clinical collaboration model, part of the reason was to help them monetize the value of their data, but part of it was to actually hook them in, to get them involved in that AI build. And we've got really strong clinical partnerships globally that have started off that way. And they really trust the AI when they've been part of the process of building it, and they've seen how it's been developed, and they've seen how their data has contributed. They've then developed benefit financially from their data having contributed. And then now what happens is for our next products, it's very easy for us to get clinics on board because we've already got a critical mass of clinical partners that know and trust the technology, are interested in other areas, and they're now coming to us and saying, hey, I've got all this data for this particular application. Are you interested in commercializing it? And so it's a really interesting approach, and I think it's just about aligning the incentives of the clinics and their need for their patients with, what we can develop as a company.
The next question is from Audrey, who says, does the Life Whisperer AI solution to help identify quality embryos require training with edge data from clinics?
I missed the last part of that question, Rohit. Sorry, you'll need to speak up a little bit.
Okay, I'll repeat the question. So submitted by Audrey, who says, does the Life Whisperer AI solution to help identify quality embryos require training with edge data from clinics?
With edge data?
With edge data from clinics.
Yeah, so it's so that if I understand her question correctly, we utilize a whole range of different data from the clinics, and this is clinical decision support. So our application identifies quality of the embryos completely objectively. It's essentially matching the image of that embryo to a data bank of tens of thousands of historical ones and looking at complex patterns that relate to those historical embryos and whether they resulted in a pregnancy or not. So we don't bias the AI by telling it the things to look at. It's a completely objective assessment. But what we have done is embedded clinical knowledge around the different parts of the embryo that are important for quality assessment. And then we've applied the deep learning approach to those different individual parts of the embryo so that we're embedding clinical knowledge as well as brute force kind of deep learning approaches to identify complex patterns and features. And then when they use it in the clinic, they combine the assessment that we provide with a whole range of other things that they know about the patient. So there is really clinical decision support, and I think that's the way it should be used. It's just one layer of information that helps guide their decision about which embryo to select.
So I seem to be getting a note that there's a bit of an issue with my microphone. Am I coming through okay?
You're very, very quiet. I can barely hear you.
Okay, I might need to speak up a little bit. Maybe that will help. So again, I guess going back to the point that we spoke about earlier in terms of the capital intensive sort of requirement to get healthcare products off the ground earlier. Again, for any healthcare founders that are listening to this particular session, is there any advice that you can share in terms of your own fundraising journey, or I guess how you've sort of overcome some of the challenges of the initial hurdle of getting healthcare products off the ground?
Yeah, it's a really good question. So I actually founded a previous AI company in 2007 that was not in the healthcare sector. And that was very intentional because really we wouldn't have had the means to develop anything for the healthcare sector at that particular point. It was quite difficult and quite expensive. So we ended up being acquired by EY, that particular company, and then we kind of had the means to self-fund the first 2 years of our clinical studies in Preston, which was a really fortunate position to be in. And then once we had proven that this was a possibility, that it was feasible to be able to use AI and computer vision to select healthy embryos, we decided that that was the point in which we would go seek seed investment, which we did at the start of 2018. And then we're now at the point of growth. We're now in multiple countries. We've got regulatory approvals. We're ready to kind of grow and scale, and we're ready to develop all these other products on the basis of our platform. So we're now raising a Series A round to be able to do that.
Another question that I've got submitted is from, I believe, Hip Money. It says, love all of this. My question is, what can the ANZ startup community do to help Precigen in 2021?
Yeah, interesting. So I guess it's all about collaboration, right? It's all about cross-pollination, helping each other, helping kind of develop industry here. I think one of the interesting things, I'm part of a lot of the AI working groups nationally, and it's actually a really challenging industry to work in within Australia. And it's challenging because there's not a huge amount of technology investment here for the life science sector. So that's quite challenging. So I think it's about kind of helping each other to leg up and get to the stage where we can demonstrate scale and demonstrate value to the extent that investors are willing to invest onshore. I think that's been our biggest challenge, is there's a lot of kind of offshore investors in the US, for example, that understand this space really well. There's not a lot of Australian investors that understand this space well. And it's a shame, because I think Australia's kind of poised to be a really thriving technology innovation kind of community. We've got a lot of talent, a lot of really amazing startups working in these areas, but they need to be able to be sustained. And capital is a big part of that, particularly in the healthcare context. If you're a software product that you can make revenue from day one, fine, who cares, right? There's other ways to kind of generate revenue and grow. But in a healthcare startup, you just can't do that, because you can't take products out until they're built, clinically tested, regulated, and it's capital intensive. So I think, it's about collaborating, it's about trying to help each other to build value and, drive experiences from each other and build a really robust, mature community here.
Yeah, great advice. And I think we've got time for probably one more question. So the question's from David Lamond, who says, Michelle, any insights for the development and scaling of health-related products that are not medical devices, but necessary in health context nonetheless? We have a remote location and operational status monitoring device for AEDs. We're hoping to launch to market in 2021.
Could you just repeat the last part of that question? I'm so sorry.
That's okay. I'll repeat the whole thing. So, Michelle, any insights for the development and scaling of health-related products that are not medical devices, but necessary in health context nonetheless? We have a remote location and operational status monitoring device for AEDs. We're hoping to launch in market in 2021.
Interesting. Wow, that's a really broad question. I mean, I'd be happy to have a discussion offline, but there's different challenges that exist in the medical device space than in other areas. And I would say just understand the regulatory landscape of that particular device and try and build to those standards, understand the compliance measures that you're going to need to meet, understand how to engage early with critical stakeholders so that you can develop the product, if you haven't already, with the end customer in mind. And yeah, I would just say, happy to connect after if there's any other kind of broader experience I can bring to that.
Fantastic. On that note, Michelle, thank you once again for sharing your insights and your experiences with Life Restore as well. It's really fascinating, and I'm sure we'll all be following your story.
Thanks so much. Thanks, everyone.
And that brings us to our final session for today, Building the AI Ecosystem. A big thank you to all of our panelists for joining us this afternoon. Tim Bradley, the General Manager of Emerging Technologies at the Department of Industry, Science, Energy and Resources. Sue Key, who is the CEO at Queensland AI Hub. Andrew Lai, the Managing Director of Boab AI. And Anton van den Hengel, who is the Director of Applied Science at Amazon and Professor of Computer Sciences at the University of Adelaide. I'll leave you all in the very capable hands of AWS's Head of Startup Ecosystem, ANZ, Colette Gergich, who will help lead this conversation. So I'll hand over things to Colette.
Thanks, Ro. That is a mouthful when you have so many accomplished people on one panel, hey? Just welcome to everybody. We've got about 45 minutes together. We'll do a quick session where I'm going to ask a couple of questions. I'll kind of ping around the room a little bit, and then we're going to leave some time for Q&A at the end. And really what we're looking at today is that overall, growth in AI ML in the past decade has just been, hockey stick, and a lot of that has been driven by computational power and algorithms and libraries, and then specifically also access to data. But one of the biggest obstacles to growth has actually been, and continues to be, talent. So for example, in Queensland, there are 8 times more AI jobs in the state than people with the right skills to fill them, which was quite a big number when you think about that. And for me, that sounds like an enormous opportunity for Australia. And we're at a really exciting stage where we're seeing organizations starting with the same mission to build capacity and capability in Australia for us to actually seize this opportunity and to put us in a very good competitive space globally. And today I'm really excited to have this powerhouse panel that represents all these different organizations across the ecosystem who are all aligned on the same mission. So Tim and Anton, Sue, Andrew, welcome and thank you so much. What I might do is kick off with Tim, because Tim, you've got a background in economics, so obviously that strikes me as a bit of a trend spotter and someone who likes to design the board game itself rather than just playing the game. So what do you think are some of the key decisions that Australia should make and levers we can pull now to set ourselves up to win this ever more digital and data-driven future?
Wow, good question, and thank you so much for inviting me on. We've actually got we've been doing a lot of work in the AI space, policy space for the last couple of years. And we had a national summit, I think, last year. We've done a lot of work around AI ethics. We've had some initiatives being kind of successfully go through the budget. And I think the next natural step is really an AI strategy for the nation. And I'm so happy to say, I think it was last week or just the week before, we were actually able to put out a consultation paper around the building an AI action plan for Australia, which would kind of hopefully set the tone about where we want to go. And within that, we are looking at kind of what's the role of business, both in terms of developing technology and adopting the technology as well. What's the role for the research sector? How do we plug that in with industry, focus, coordinate, and so on? What's the role for the workforce, both in terms of pipeline and facilitating the current workforce to adapt and to engage with technologies, and also on the society side. So socially, it's the ethics question, it's regulations, it's the role of government as exemplar, and so on. That's a really holistic view of things, and it's kind of when you start going down this question about what does Australia need to flourish when it comes to AI, it becomes very much almost an economic strategy, and it's boiling the ocean and trying to do certainly an awful lot. Then there are questions around data as well, and there's always kind of a big emphasis on public sector data, but I think we're certainly keen to look at private sector data as well and what offerings are available there. I think there's an awful lot of kind of untapped private sector data that can benefit here. And then of course, computational power is again another investment or a question mark around how much do we need now, how much do we need in 2030 is going to be a good question.
Wow. I was going to say, this is a rabbit hole. We can go in so many directions after that. Wow. Maybe what I would flick back to you, because, you know, for the audience, this is probably an area that they would like to know about too, but which industries do you expect to benefit most if we get it right?
So Sira did a piece on this, Data61 did a piece on this, the AI technology roadmap, and it was quite a comprehensive study. And it's very interesting, I find. So when we talk to the Microsofts and the Amazons and the Googles of the world, you know, when they talk about their capabilities and kind of where they're investing, it's very much in technology specific. So it might be natural language processing or ML or neural networks or whatever it is, and they've kind of got advances going like that. Whenever you talk to government, it's very much more sector specific. And the Data61 report highlighted 3 areas which probably of no deep surprise that would benefit an awful lot from AI and kind of where Australia has kind of competitive advantage. That's in the natural resources and environment space. It's in cities, so better cities, so smart cities, and also in healthcare. And I'd say, I mean, when you look at the Australian economy, they're probably the obvious choices that you take, and kind of growing sectors or things that we have a lot of stake in. But I don't want to limit it to that. I think we've got some awfully strong niches, in particular in the space, through clean tech, through biotech and medtech as well. Like I think it's dangerous to limit too much focus to too much areas. And I think there are pockets of investment that you want to kind of drill down into those verticals, but I think it's really important to have that enabling horizontal that goes across the whole economy that all sectors can tap into.
Wonderful. And we'll come back to some of these big problems a little bit later. I might switch over to Anton, because you wear multiple hats as an expert in applied science and AI. Like, you're a professor at the University of Adelaide, you're a director on a number of institutions and organizations, and then you're also working on some cutting edge projects within Amazon. How did that come about? And let's talk a little bit about that connection between research and industry, and how do we make that work better?
Sure, thanks. So yeah, I'm the director of the Australian Institute for Machine Learning, which is 130 people doing research in machine learning, particularly computer vision, at the University of Adelaide. We're number 3 in the world in computer vision publications over the last 10 years. And I'm also director of applied science for Amazon, which means I'm running a team in Adelaide. Well, the team's all over Australia, really, but that's a growing team, and quite a quickly growing team here in Australia, actually solving problems for the Indian retail business. And I think that's a very important model. So Australia is a really good place to set up these kinds of centres of excellence, or centres of research expertise in all sorts of fields in science, but particularly in machine learning. There's an incredible amount of competition for people with machine learning skills all over the world, and that's visible in the fact that there's 8 times as many jobs as people in Queensland, but it's also visible in the fact that PhD students straight out of their degree regularly get 350 grand a year US if they move to California. It's a field that is where there's an incredible amount of demand, and that demand's not really going to go away. It's not a flash in the pan. It's not it's not temporary, because the technology adds so much value to every business. And my answer to your previous question is, you could pick industry sectors for impact now, but so the places it will have the biggest impact in Australia are the places that we have the biggest industries in Australia. Just because that's the best place to leverage, but the long-term impact will be that it creates entirely new industries here. And Australia is really well placed for that, for the same reason that Amazon came to Australia to try to set up a research group, because people want to live here. we have a bunch of really good conditions, and people are willing to, frankly, take a pay cut in order to stay here, move here, live here, and do this kind of research, because it's Adelaide's just been, voted the most livable place in the world again, because it's, safe. You can buy a house, you can get to work in 15 minutes. The sun shines, you're 15 minutes from a beach and the hills, wherever you are. These things that we kind of take for granted as Australians. There are people clamoring from, very well qualified people clamoring from all over the world to get here. And that puts us in a really powerful position. The new visas are quite good, but we as a nation need to leap upon this opportunity to gather those highly qualified people and bring them here and get them ensconced, because they're the people that create these opportunities, right? So
how do we, conversely, I want to, before I, obviously hand over to Queensland to rebuttal the most livable place in Australia, but maybe before we do that, Anton, tell me a little bit, because there's it seems like a big focus on getting talent into Australia with the right skills. So what are we doing to make that, homegrown talent, to foster a greater pool of talent within the AI and within the data sciences, really, here in Australia? What do you see universities doing now that's maybe different? And what would you like to see more of?
Well, to tell you the truth, I think Australia has been very slow to invest in this area. We have a kind of history of being really, of doing really good research in this area. And you can see it. So about 3 years ago, we were looking at where all of these groups, Australian groups, ranked in the world. And I can't remember exactly, but there were 7 or 8 of them that were in the top 5 in the world. If you go back now, and so those groups have been turning out really well qualified people for a long time, and most of them were going overseas, frankly. Now all of those numbers are slipping. Everybody is just dripping off the precipice, and the number of groups in Australia in the top 5 is a fraction of what it was just 5 years ago, because everywhere else in the world is investing. And not investing small amounts, like literally investing billions of dollars, right? South Korea has just put $2 billion in. Germany's put billions in. The US has been putting billions in forever. The Chinese have put tens of billions in. We are competing in a great big pool, and we have this fantastic resource, this fantastic history, and this great background, but we're just not exploiting it. And I must admit, it's a real shame to see us constantly losing this battle against places that have more insight, frankly, into the future of what this technology means. We've lost this battle before. We were very big in chip fabrication at the beginning of the Silicon Revolution. We had I think we built the world's 4th modern computer in Australia. I think it came out of CSIRO. It was called CIRAC. Amazing, right? Really, that's real history-making stuff, right? It should be on the flag. That's incredible. Yeah, we've done incredible things in this country. We have this great tradition of being there early, pioneering, and then giving up when other people invest. And I'm afraid that's what's happening right now, and it's a shame to see. But we're better placed than most to leap upon this opportunity, and the way that you do it is to have these people. You need to have the core capability that spins off. In Amazon, they call it the flywheel, right? You need to have this core capability to spin off the people and the capability that drives that economic activity. And I'm afraid we're losing that capability overseas.
And I suppose that's why we're all here, is because we want to know how do we accelerate that and get back on the front foot. And with that, I might go to you, Sue. So first off, congratulations on taking the CEO position, the Queensland AI Hub. It's fantastic to see an organization like that come about, and they've absolutely picked the perfect person for this. because before that, you've also been very impactful in building out capability and community for robotics in Australia, including pioneering the development of Australia's first robotics roadmap. And there's such a big, connection between robotics and AI, and both of them are very technology oriented. So I think the question that I'd love to hear from you is, does this mean that you have to be a technical person, like an engineer or a software developer, somebody who already has those base skills to, wield the power of AI and create value and solve problems with it?
I think there are different answers to that question. I think to Anton's point, to really build up an industry here in Australia and see the most benefits, then, what we critically need are people who have very specialised skills, because without them, it's really hard to build up an ecosystem around them. But definitely within the AI ecosystem, I think that there is a lot that different people can contribute. And I think another thing that is holding us back is a general lack of awareness of what these tools can offer us. And I'm not sure I have the answer to that, but I think, if you look at an area like robotics, one of the easiest ways to reduce people's fear over those sort of technologies is to actually get them into people's hands. And I think that's something that we need to aspire to do with artificial intelligence. And I'm not 100% sure what that looks like, but until people actually get the opportunity to, touch and feel and play around with it themselves, then I think we're always going to struggle with it being an abstract concept that people don't really fully appreciate how much it's impacting on their lives, and how if they, if they don't get behind Australia embracing this technology, unfortunately the rest of the world, as Anton described, is not waiting for us. And we really need to be, everyone needs to be pushing for Australia to have a grand ambition in the area. So Anton mentioned Korea. The reason they've invested $2 billion is because they have decided that by 2024, they want to be one of the top 4 AI countries in the world. And you can put metrics on that. What does that look like? Why we need to be aspiring to do exactly the same thing. And I don't think that we can get the support for that unless we are engaging with people outside of your AI specialists. So
can you maybe tell us a little bit more about the AI Hub and what your grand ambition with the AI Hub is and what you're currently busy working on?
Yeah, so I can't complain. The Queensland government has invested in the AI Hub as a way to build the local AI community. And really a lot of our role is about showcasing the local AI talent and technologies that exist. Some people outside of Queensland don't realise that Queensland actually has quite a few strengths in technology. We produce 60% of the world's mining software. We actually have Australia's strongest capability in cyber physical systems, so, which you could think of as the physical manifestation of AI. And so there are a lot of indicators that would suggest, and you've already mentioned the number of job opportunities available in AI, which is a good indicator of the activity level that's going on here. But at the moment, it would be fair to say that it's quite fragmented and immature, and it really just needs to have a catalyst to bring all of those fragmented activities together and to really showcase that, so that we can see more investment happening, and so that we can see examples like Anton, where Amazon has decided to actually set up an R&D centre here in Australia, which sadly is very rare for many of the multinational companies to consider Australia as an R&D base. We often only have sales forces out here in Australia. So we need for the perception of Australia to change, because I think Anton also really well described how much Australia already is actually, the strength that Australia already has in the area. But, I think we keep it a well-kept secret. And it's hard for people to get something behind something if they're not even aware that it happens. And the reason that the Queensland AI Hub formed was because of a high level of interest in AI from amongst the AI community. And really, we just want to, surface that and try and harness that so that, we can build a proper tech industry here.
Yeah. So it's like, all the little snowflakes coming together and causing an avalanche. And that's really one of the objectives of running the AI Conclave is to bring people together and to really illustrate that there is actually quite a lot happening out in the community from entrepreneurs, from researchers, so that we really build that momentum. And with that, I actually am dying to ask Andrew a question, because you're also no stranger to the startup ecosystem, and you've been a catalyst in a number of other initiatives across fintech and ad tech and university ventures. And now firmly also into the world of AI as the managing director of BOAB, which is an accelerator for AI scale-ups specifically. Can you tell us a little bit more about the program, how it came about, and why you think the opportunity is big enough to run a dedicated AI accelerator here now?
Yeah, sure thing. And thanks a lot, Colette. So essentially, BOAB AI is a scale-up investment program. So I suppose similar in respect to an accelerator, but our offer is $300,000 in equity investment, and then it's a 6-month program to deliver a tailored assistance program. So it might be investment advisory or enterprise sales, etc. So yeah, the opportunity, I suppose, came about mainly because of some of the data that we've been sort of grinding through, and we've realized that, and I've been quite surprised by it. I sort of understood that there was a little bit of a funding gap, but didn't realize the extent of it. But Australia's GDP footprint is 1.8% of world GDP, but Australia's share of global AI funding is 0.29%. And so it's about 1/6 of what it should be. So my view, coming out from a commercialization unit of a university as well, is that Australia's got incredible talent, incredible research, incredible people, but the commercialization of that is, and that's something that's been cited time and time again. It's perhaps an area to be improved upon. And yeah, that's the opportunity that we've cited, and we've just completed our applications campaign and have been very pleasantly sort of surprised by the amount of companies that have actually come forward, that have developed products that are in market, but time and again, the feedback we've received is that it's very difficult to find AI funding out there.
Yeah. So when you think about some of the other areas that you've worked in, like with fintech or with Spradix from an ag perspective, and how they've all kind of started from nothing similarly, and now there's these little mini ecosystems around them. What are the things that you think made it work?
It might be a bit of an aspect of, I suppose, Australian culture, but there's tons of people that I've just met, just as eminent as the other panelists over here, that are just fantastic in their realms and absolutely world class. But anecdotally, sort of out in the ecosystem, I've found that there's perhaps people aren't as explicit about talking about how good they are and how world class their technology is. So look, as much as it might be a little bit daunting, but I think a little bit more marketing perhaps in the Australian ecosystem goes a long way to sort of gather people, and it very much is world class. I mean, the anecdotes that I've received from US investors is that, look, for the check size that you're offering, you won't be able to get companies that have actually got a product. It's just going to be idea stage, or they're just going to be ideas. But that's completely not the case. We're very much getting fully developed products, companies with large amounts of revenue that are in market, enterprise customers. So it just goes to show, I think, that the sort of local area has a lot more deal flow than there is funding.
Really interesting. It's all the little pieces that make it work. So I guess the question that I have going back, and this is now where the gloves come off, and I hand over for you guys to debate. But are we doing enough? Who's going to take this one first? Anton's going to.
Yeah, I'll have a go. I think we've made a bunch of the right inroads, and there is a narrative really that along the lines of part of the reason that people want to come here, and that part of the opportunity here is actually the investment we've already got in institutions that work. So we have a really good education system, but we've also got kind of a set of liberal democratic institutions that are really valuable. And it means that we have the opportunity, for instance, in AI specifically, to launch a brand in Australian AI that people can trust, right? For the same reason that people buy Australian fruit preferentially and buy Australian milk powder. It's because we have this kind of set of liberal democratic institutions, and that's a great. It's an particularly in Australia, we don't recognise the value of that enough, right? We don't take it seriously enough. And there's a few other bits and pieces, and frankly, we're a very rich country, and so we have a whole lot of the pieces required to put it together. What we don't have, however, I'm afraid, is a culture of innovation in companies. We spend a lot of time talking to companies, and a lot of them are, and even the very biggest ones, just don't have an innovation budget. They don't have an innovation culture. They don't have an innovation board member. They don't have innovation reporting. They're just fundamentally not prepared. Right? It's very rare that somebody comes in to the Institute particularly and says, we want you to work on this, and we're prepared to go and raise the money required to see this project to completion. We get 300 people, 300 companies a year coming into AIM or wanting to talk to us, but they all want to do, they want to find out what AI is about, or they want to run a small pilot project. The number of Australian companies that are actually ready, have made the intellectual commitment is relatively small, I'm afraid. And don't get me wrong, there are some fantastic exceptions, and I always call out LBT Innovations for that, because they really are an amazing company for exactly that. But the obvious thing is that a lot of this comes out of core capability, right? So Google wasn't formed by a bunch of people who'd inherited a small search engine and wanted to make it 10% bigger, right? Google was formed out of two people doing a hardcore PhD or PhDs at Stanford, who realized that actually web search is a matrix inversion problem, and leapt off from there. What drives this area is core capability, and we just have to, invest in core capability, and that's what
I would challenge you on that one a little bit, because I do agree that core capability is super important when we think about entrepreneurs and seizing the opportunity, and how much of when we talk core capability, a lot of that oftentimes sits in R&D, big R, little d. The translation piece is almost halted or missing, and maybe for the reason that you pointed out around that enterprise not having a big enough pool and an ask of R&D and an ask of innovation. But we're seeing so many non-technical founders tackle big problems with AI enabled, not necessarily AI and ML core, but AI enabled solutions. So I almost want to flick that back to Andrew and ask you, are you seeing the same trends, or are some of the companies that predominantly, are they technology or non-tech founder based?
Yeah, there's definitely, I think, a bit of a mix. There's, quite a few companies that I've met where everyone's got a PhD, and that's been, extremely sort of amazing, because everyone's just so talented and it's just got so much technical ability. But you're right, there are definitely some companies that are, for example, using the AWS stack to just create, new tools. And I do very much have that theory sort of out there that a lot of the technology is just, available, that's, in libraries that could be just called upon to be used to, do perhaps the AI sort of machine learning sort of component. And it's just matching a lot of that to the use cases that are out there, because there's just so many, I suppose, the industries. And, I suppose my background was in ag tech, and, some of the very successful companies that we had come through from our portfolio were very much non-technical founders. And, they bit of a what's the word for it? It's a bit of a trend to sort of say it, but it's, you've got the hacker, hipster, and then the hustler, right? So often if you do have someone creating the product, you sort of also need someone that raises the money and then gets the customers and helps to sell it. And very often you don't have one person that can do all of those things together.
Don't get me wrong, I agree completely that you need a set of skills in a company. It's just that, frankly, there's no end of hipsters and hustlers out there. What we're short of is hackers. And if you want to create a global business, then there's no end of people with the ambition of creating a global business. The ones that do it are the ones that have distinctive technical capability, and that there's this feedback mechanism in these ML business models where you get your 5% better and it gets you 50% more customers, and then that gets you the data to be another 5% better, and you just ratchet up to the point where you've got an unassailable data advantage.
Dominant.
And so back a little bit, Australian research funding does tend to focus on translation over core capability. And I'm afraid that translation is wonderful, and we need research translation funding, and Australian companies aren't doing it by themselves, and so they need help. But you can't translate non-existent research. You have to have the core research capability, because that's what generates the research to be translated. But it's also what keeps the staff. If you want to have people to go and fill these 7 spare jobs that we've got in Brisbane for every existing one, they need to be trained by somebody. And the people who train those people are academics. And the academics need to be, we have to pay the academics, right? And if you don't put the core research funding in, you don't get the academics, and so you don't get the students. So, you just have to have, and that's the flywheel, right?
I can see Tim frantically taking notes, but Sue, I am dying to hear what you have to say about this, because this is right up your alley.
I guess Anton makes some good points about, I agree, without that core capability, we can't do anything. But, I think, as I've said before, you can have different backgrounds to be able to contribute. And sometimes, the people with the good ideas, might not necessarily have that specialist background. So, what we see in terms of the startups here is a mix of AI specialists who have started their own companies versus other people who've had the idea and then built a team who have that capability to support them to develop it into a business. But actually, I'd probably like to find out, Andrew probably has the stats on this, but, going back to the lack of R&D investment by Australian companies, I think that is also something that is a problem for our venture capital system, in that Australia has a very low rate of institutional investment in startups, and I'm not sure whether that is something that we could aspire to change. But as it really does come back down to the dollars. So, we need investment at a couple of different levels. We need to be able to ensure that when we are starting up these businesses, that they can access the capital that they need to be successful, and so that they don't have to consider moving overseas. Sadly, what we do know is that, at least for robotics companies, many of them don't even seek investment here in Australia. They will go straight to somewhere like Silicon Valley. Who knows the chain of benefits that we're missing out on because we're not telling a good story. And I guess this goes back to the heart of what Anton is saying. If we don't actually put out there a clear signal to the rest of the world that we are serious about artificial intelligence, then why would anyone take us seriously? Why would people want to move here? It has a whole range of flow-on effects, because I don't believe we're being clear that we want to be good at AI. And we need to define that, as Korea has done. Like, what are we saying here? Do we want Australia to be, number 100? I hope that's not the case. But, we should actually put it out there. What is it that we want to be?
I love this, and I feel like this is the perfect spot to put Tim back on the spot. I can see him looking at me. Tim, how far away are we from having that big, bold vision?
So just maybe I'll just address a few things that kind of said then. So I guess Anton's point about research funding favoring translation, and I know this is not what he was trying to infer by that, but it's kind of in this holistic view of how do we solve this problem. I'm not convinced that further that's the silver bullet to this question necessarily. I don't think that's what Anton was saying either. We heard Andrew talk about it. I think we heard Anton mention this as well about the problem Australia has with commercialization, with the innovation system writ large, kind of being a problem in culture and so on. And I think Sue's bang on the money there, where she says, that investment needs to happen at a couple of levels along that supply chain. I think in the past, when it comes to the innovation system, the investment into that basic research, into research in general, I think has led to some success. As Australia boasts a number of universities through Queensland, Adelaide, Sydney, UTS, Data61, which is not a university, of course, but the research centre that are certainly punching well above their weight in terms of research impact and so on. And I think it's a real strength of the ecosystem here. Whether or not it's got sufficient investment or not, that's another question, and maybe it needs to be scaled even further. But it is a positive. Also, it's really interesting to hear people talk about kind of brand Australia and kind of not positioning ourselves effectively overseas. I've just spent the last couple of years in Washington. Kind of, I was posted over there and working with the Americans and the Canadians and G20 and whatever else. And it's actually really interesting to hear Australia be used by other countries about why they should increase their investment in AI, because of countries like list Australia and others who are punching above their weight and doing great things. So it's really interesting to hear that internally, kind of the way we think we're being perceived abroad. I'm not sure. How far are we away from that big vision? So we are consulting now. We're kind of going broadly. We are in a very legitimate, next budget is coming up, discovery process, asking for people for ideas. What do they think the vision for Australia should be? Do we need to have a target like South Korea have? Do we need to have a focus? Should we be putting our eggs into the kind of healthcare, natural resources, cities basket, or should we be expanding more broadly? What does that vision look like? I think we really want to hear that. And then once we have that, I think that's actually a really powerful thing. And I've seen it in other sectors, such as space, for example. We have a space strategy which came out a year or two ago, and watching industry, research, government all line up behind this kind of common message for the space sector and saying, this is where we're focusing, this is what we're trying to achieve. It's been a really, really powerful thing. And I'm super hopeful we can do a similar thing for AI.
That sounds exciting. Sue.
Oh, yeah, sorry. I just wanted to ask Tim, what is the quantum of investment that has happened in AI? Because unless I'm mistaken, it is nowhere near our peer nations. And just a challenge also, maybe things are different on the East Coast of the US, but I spent time talking to people on the West Coast, expats, trying to convince them to come back to Australia. And the common message that they gave me was that they were waiting for some indicators that meant that Australia was serious, and that if they were to come back and do what they'd done in the States and set up successful businesses, that they would get the support that they required. And they weren't confident that they were getting the messaging from Brand Australia that would be the case.
Yeah, and I think there's something to that as well. So I'm not totally surprised by the messaging here, but I'm saying that it's kind of, I guess, within government circles, that was kind of Australia was being used as an exemplar. But I'm not. I obviously heard those kind of stories as well. A lot of expats that I'd love to come back. It's just that's where the industry is and that's where the focus is and so on. I think one of our key tasks right now as we're writing our strategy is to provide that coordination and say, yes, there are pockets of excellence across Australia. How do we combine those? How do we leverage them off of each other and coordinate into a way that really tells our story? I think that's a really important part of the piece.
Well, where do we go from there? Look, I tend to, I'll just, not that I'm participating on the panel, but I tend to agree that so much of every time that we start with the company, you go, what's your vision? What are you trying to achieve? And it would be absolutely fantastic to see something that's bold and that's concrete, that, like you say, then everybody can just shut up and get in line and start lining up, because we do have so many of the pieces, like incredible pieces with research, with universities and enterprise and startups all ready. It's just about that coordination piece. And Tim, sounds like you're putting your hand up to take input. So that's really wonderful. Thank you.
Oh, yeah.
I wanted to maybe flicker back to you and say, if ever there was a time to think about perhaps, AI gets lost in a number of priorities that the government has to run, or that, we as a nation and people and individuals have to focus on. And if ever there was a time to start thinking about, what are some of these big problems that are coming us and punching us in the face? Is this an opportunity to use technology, or to basically, sneak technology in as a solution to some of these big problems? Do you think that's possible, A? And what are some of the big problems that you would like to see people leverage this technology and actually make big step changes in?
Can I start off then?
Yeah.
I think that, a lot of people in the space found it quite disappointing when Australia was faced with those devastating bushfires earlier this year, that we weren't in a position to be deploying some of our great knowledge in terms of how you deploy sensor networks so that you can be collecting information, I guess, calling it autonomous biodiversity, how you can, without having to have people involved, be getting a good sense of, what is the flora and fauna of an area, how is it impacted by bushfire, how is it regenerating? We shouldn't be relying on people who are going out on walks, collecting some, pictures on social media. We actually have the technology to be able to go out and get that information at scale. But, at the time the bushfires happened, we weren't set up to do that. And so I think the potential for these technologies to have a huge impact is there. And I'm not 100% sure what are the pieces of the puzzle that need to happen so that the next time we're faced with such a situation, or a natural disaster, that we can deploy these, more rapidly. But certainly the potential is there, because, who knows what we lost during those devastating bushfires. It's hard to know because we weren't collecting the data. We weren't collecting the data before the bushfires, and I don't think we're doing it effectively since the bushfires. So I think that's just one example of where we could have a huge potential for impact.
How about you, Andrew?
Yeah, I think the bushfires example is an excellent one. Sometimes when I think of AI and what role it could play within Australian society, it's just that general idea of productivity gains. And I think I've checked out the stats over the years that, in fact, Australia doesn't have a lot of productivity gain, and just feeding into sort of any industry. And once again, to use all the cliched terms, we at BOAB, we don't refer to AI as a vertical. So as an industry, we sort of refer to it as a horizontal. So it's a technology that could be used, throughout any industry, and, add some productivity gains to those industry. And, obviously, Australia is very much in need of that. The mining industry, for example, obviously, I think the statistic now is that solar energy is the cheapest type of energy that it's ever been. So coal's the number 2 export of Australia. So Australia sort of does need to find other areas to help stimulate the economy. And of course, with COVID occurring, there's a lot of economic activity required. So yeah, like across the board, I think there's gains to be made. But of course, I'm also just very passionate about the role that AI can play within agriculture. So from my days in ag tech, I was very cognizant that a lot of the farming practices that we have out there are just so extremely manual. Some of them have been used for 50 years or hundreds of years and haven't really changed. Of course, there's some very advanced farmers out there, but over 90% of farms are sort of family owned. And so I think there's opportunity out there for extreme productivity gains, particularly in the realms of computer vision and robotics within agriculture.
Cool. Anton, what are some of the big problems that you want to see tackled with AI?
All of them. So yeah, I agree. Yeah, I agree completely with Andrew that it's a horizontal, and that Australia, well, as far as I'm concerned, I don't think Australia should be trying to compete with the rest of the world on lowering wages. We don't want to be the place that people come to build stuff because we're cheap. We want to be the place where people come to build stuff because we're smart. You've got to go one way or the other. This is the technology that's going to drive it will be the major driver of productivity gains in most industry sectors across the next 20 years. And we will be competing with the rest of the world on that basis. So there's a narrative around that we'll just wait and import our AI from overseas, which I think is a recipe for disaster. We are competing for AI capability with the rest of the world because it drives productivity in every industry. Our agriculture sector, the future of our agriculture sector depends on our ability to use AI to improve productivity and to improve product value. Right? The future of our mining industry depends on AI to reduce costs and improve value. The future of our manufacturing industry, the only way we can run a manufacturing industry is to be smart about it, right? Cars are an AI problem now, and everything else is going that way, right? Phones are an AI problem. Everything is your toaster will be an AI problem, right? And the next pair of shoes you buy will be an AI problem. Everything that we make will be an AI problem. And, from working inside Amazon, pretty much everything they do is a machine learning problem. Our global competitiveness depends on our productivity, and our productivity depends on AI. If we wait and try to import this gear from overseas, we'll have no competitive advantage, right? We'll just be another place where Californians come to make money, right? We're already subject to Facebook, Uber, and Google coming in here and making a lot of money and not paying very much tax. And that, that's just the first few industries, and that trend will continue. And the only way that we maintain competitiveness and, frankly, maintain sovereignty is to be an active participant in this process, not just to be a passive victim to it. And being and just waiting for other people and importing that tech and importing their products is a recipe for disaster, I'm afraid. There are industries that feel that they're protected. The taxi industry thought that they were protected because they bought plates and they paid a lot of tax. Turns out they weren't protected at all, right? They were one of the first to go. The medical industry feel that they're protected because there's, they've got patients on the ground and there's a lot of regulation. The next generation of startups from China will be doing medicine cheaper and better than can be done here, and it would just go offshore. The regulation will be irrelevant, and that process, like everything else, will be globalized. We need to be an active participant if we're going to have a seat at the table. People talk about the ethics of AI and how it will be regulated and all of that. When they talk about regulating the space race, Burkina Faso doesn't get a vote. And we will be Burkina Faso in that process, right? We will be just another country where Americans come to make money that doesn't get a vote. So, if we want to maintain sovereignty, and if we want to actually participate in this industrial revolution that we're in the middle of, right? This isn't something that's happening in the future. This is right here, right now. You're watching it, right?
Yeah.
You're watching Australia go backwards. And if we don't want that to be our fate, then we need to take dramatic action right now, as far as I'm concerned. But, what would I know? I'm just...
What a better call to action. We do have, I mean, I could sit and listen to all of you for days. I think this is a very important topic that we need to spend so much more time on. But we have one question that I just didn't want to let go. So we're going to have one question, and then we'll see how long that leaves us with, and we might have to wrap after this. But Brian Doricott, hi, Brian. Sue, the underlying message I'm hearing is that entrepreneurs in Australia wait to be told what to do. My understanding is that in the US, the mindset is that they go out and do it. They don't wait.
No, I'm sorry if you heard that message. I thought what I said were that Australian entrepreneurs go to where the capital is, which is in Silicon Valley at the moment, at least where robotics is concerned. So, and really I was talking about the messaging that we're giving to the rest of the world. So to expats who are over in countries like the US who have built up successful businesses, when they look back to Australia and think about moving back here, as many of them have done due to the political climate over in the US, you know, they want to have some surety that, you know, the situation has changed since when they left. And I'm not sure we can give them that surety at the moment. But no, I don't agree at all. I'm sorry if you got that message, but no, I'm not saying that Australian entrepreneurs just sit back and wait. Not at all. I mean, I think unfortunately Australian entrepreneurs don't sit back and wait, and that's why we're losing them.
Yeah. And Anton, Jody Granger says that you definitely need to go on Q&A on this one. So keep that one in the back pocket. I just want to summarize a few of the trends that I heard from you. And I will do this in a basic 5-year-old style. There are many big problems in the world that we need to solve. AI will solve all of them, but not if we can't build the talent and the capability here to solve the problems that we need solved in Australia. And I think that that holds true. And I just want to commend each one of the panelists who are in their own ways coming at this problem and trying to figure out, how do we teach people better? How do we connect people better? How do we provide more capital and support and training and mindset and opportunity so that we get entrepreneurs, so we get industry stepping in and actually participating in this space more effectively, and setting us up for success for the future. And the other thing that was a big takeaway is that absolutely, we are looking for a big, bold, ambitious vision, and then we will happily shut up and get in line. So with that, I just want to say thank you again so much to Tim and Andrew and Sue and Anton. I've really enjoyed this conversation. I've learned a lot. It's given me some food for thought for what can we and what can I, within this position at AWS, do to bring this community together and to build more momentum and capacity behind this, because I think this is a super exciting opportunity for us as a country, and for our entrepreneurs and for the people who live and work here. So I just want to say thank you so much again. It was an absolute pleasure, and I'm going to give you 9 minutes on the hour back, because who knows, you're probably on another video call back to back, as it is these days. But yeah, thank you so much.
Thank you, Colette.
Thanks, Colette. Cheers.
Thanks.
Thanks all. Bye.
Okay. Thank you all for that, Colette. Thank you for moderating as well. And to all of you, a big thank you for joining us. That concludes day 1 of the AI Conclave. Please join me in thanking our fantastic panelists, Tim, Sue, Andrew, and Anton, and Colette for doing a fantastic job for moderating, and all of our speakers today for so generously sharing with us all. Lots of food for thought. Although that ends day 1, I'm super excited for tomorrow with a host of tech talks and some crystal ball gazing and valuable insights from our VC Fireside Chat, which will close out the conference. Keep an eye out in your inbox this afternoon for the live link for all of tomorrow's sessions, and we'll look forward to seeing you at 10:30 a.m. tomorrow as we kick off day 2. Enjoy the rest of your day. Thank you.